than I do. I just sat in my bed and watched YouTube videos at like 4 in the Good morning. Welcome to Web Rebels. Woohoo! I'm Jameson Dance. I'll be the MC. I have a couple of announcements. First of all, Web Rebels has a code of conduct. You should all have read it as part of the ticket buying process, but you can find it on the website. The organizers and event staff are around here in the yellow t-shirts, so if you have any questions, any issues, anything, come find one of them. They'll be happy to help you. So there's not gonna be a live Q&A after the talks. Well, actually, how many people have been to Web Rebels before? Raise your hand if you've been here before. Okay, a ton of people, but lots of you haven't. There's no Q&A after the talks with questions live from the audience. The way we do it is you'll tweet with the hashtag WebRebels, and then I'll be just scrolling Twitter like I do in real life. I've practiced a lot for this, but this time it will be with a better purpose. I'll look for questions that seem interesting and helpful to ask, and then we'll sit down casually on this couch and just have a talk in front of several hundred people about questions that you ask on Twitter. Also, if you say nice things about the talk, I'll read those too, because we want to make the speakers feel good. You should have a food card in your little badge packet thing that has 400 krones on it, and you can use it in the food hall. That's where we'll eat lunch. You also have the tokens. Those have, I think they're worth 120 krones each, which is enough to get one drink. Or you could probably exchange them with a pirate. They kind of look like gold doubloons. The party is in the hotel bar at the Hotel Scandic. That'll be after the conference, and I would love to see all of you there. So with that, I'll just introduce our first speaker. It is Mike Taylor. He's from the web compatibility team at Mozilla, and please give him a round of applause.
Thanks, everyone. Can you see my screen? Let's give it a second to boot up. I'm not plugged in, so that doesn't help. HDMI. So I'm a professional speaker. I do this for a living. No, I don't, actually. So bear with me. How's everyone doing? Can you see it? That's kind of weird. The AV guys are freaking out. Let's unplug it, and we'll plug it back in. So last night I went to bed. We can just do it like this. I don't mind. I'm just going to do that. So this lower screen is actually for the people on the tables. And the upper screen is for y'all upstairs. So my name's Mike. I live in Austin, Texas. I apologize if this gives you seizures. I work for Mozilla, and I work with Firefox. It's a web browser. And I work on the web compatibility team. And I'm going to explain what that means to you all in just a second. Oh, you're ruining all my jokes. What are you doing? It's all right. This is totally normal. Don't worry about it. Cool, dude. All right, so we're going to start again. Lol. Anyways, so this was a joke. So Firefox, free for today only. If you use the code WebRebels, you can download it. You have to put in the wow, wow, wow part, or it doesn't work. Otherwise, we charge you. All right, so that's hilarious. So what I'm going to be talking about is web compatibility. And you may have heard that term, you may not have heard that term. I had a discussion with someone at Mozilla who said, that's a terrible thing to talk about, and I disagree. So we're going to talk about a number of things, but who remembers when Firefox looked like this? Everybody's raising their hand, right? I don't actually remember. I started using the internet just a few years ago. But web pages were different back then. This was 2004-ish. And so you've got all this really old legacy content. Web pages are changing. We're adding new things to the browser. We're adding new things to the JavaScript language. And so we're trying to figure out, like, the theory is all websites should work in your browser. Anyone who's made a web page or app knows that's not so easy. And the way I try to think about this is, like, why is this important, right? So I came up with this amazing metaphor at 2 a.m. when the sun came up, as it does here in Norway. And so you think about like a drink that's really, like, you love it so much you want to share it with everyone, right? So in Norway, this is Norwegian for really good drink, I was told. I don't know how that's pronounced, but where I come from, we don't have that drink, but we have juice. I live in Texas, so we drink a lot of juice, I guess. So imagine you have this juice, and it's so good, you want to share it with everyone, right? Like, you don't want to keep this juice just for yourself. Like, even weird little kids deserve this juice. Okay, so I hate the metaphor already, but the web is like the juice, right? Like, the web is so important, everyone should have access to it, and everyone should have access to what's on the web. That's part of my dance. I was supposed to start dancing, I'm sorry. Can we do that again? So in reality, it's not quite like that, right? Like, we end up often with different experiences on the web. So if anyone here doesn't speak Spanish, it doesn't matter, because you can read numbers. So on the right-hand side, we have this message in English saying it's a 19-minute bike ride to Florida State University. On the left-hand side, same message in Spanish, but for some reason it's a 20-minute bike ride. Same path, different experiences. We'll leave it at that. And this can happen on the internet, right? So this is a super popular website, I'm told, in Japan. I don't know if that's true or not. But here we have confirmation in the front row. Excellent. Here on the right, that's what this looks like in iOS Safari. And there on the left is what that used to look like in Firefox for Android. And that seems bad. Not just a Japanese phenomenon. I'll go back if you want to take a picture. There we go. Not just a thing that happens in Japan. So OkCupid, super awesome website. I'm not sure what they do. A social network of sorts. So you can tell, right? Like, iOS Safari, old Firefox for Android. Okay, that's kind of crappy. And so web compatibility is a bit like what we do on our team is we're plumbers of the web, right? We're trying to understand, like, why everything is broken. Like, what have you people done, is what I say a lot. And so in this talk, we're just going to kind of do, like, a greatest hits of, like, watching car crashes or whatever, ambulance chasing. I'm not sure what the expression is or how that translates in Norwegian. We're going to look at broken things. So JavaScript. Okay, raise your hand if you're intimate with JavaScript prototypes. That's amazing, so I don't have to explain them, right? Like, they're super easy. Okay, so we covered prototypes. So ES6, when it was being proposed, when this was a thing, we call this, like, ES 3000 or whatever it is today, I don't recall. It had a name, ES6, at the time, and there was a proposal to add this helper method on the string prototype called contains. And you can see the method signature, how that was supposed to work. You had a search string, and you had a position where to start. So this is like, you probably do index of for this type of stuff today, or you've done that for the past 20 years. And so here's an example, right? You have Norwegian for really good drink, contains AA, that's true. The second line, does it contain AA starting at the 1th First character, false, right? So browsers implemented this. So Firefox Nightly, we implemented this, and very quickly discovered, oops, this is a problem. So MooTools 1.2, arguably the best version of MooTools, had a method on the string prototype. So they were like prototype, they added convenience methods, sugar to native prototypes. And so they had something called contains, but it had different argument signature here, right? You had the search string, but the second thing wasn't a positional argument, wasn't an integer, it was this separator. And looking at these examples, I can't remember what it does, but you can just, it's enough to know they were different, right? One was a number, the other's a string, bad stuff happens. So we implemented this, and a bank in Germany broke. And if you're in the business of web browsers and you're breaking banks, that's not great. And so how do you solve this in WebCompat land? You just rename it, right? So if you use JavaScript these days, you might be like, oh yeah, we have string prototype includes. So the decision there, the standards body said like, contains is not web compatible. Let's name it something else, and that's how we can solve that problem. Okay, another crazy issue with statements. You should not know what these are or use them ever. And I'm actually probably just going to skip this refresher, but well, let's cover it, right? So if you have this really awesome method called getValues, you pass in a thing, and then you've got this with statement, right? So you've got with an expression. Expression is the thing, and then you've got the statement, which is return values. And so what that does is that broadens the scope lookup, right? It augments, so scope lookup normally happens in the execution context of the function or script you're running. And with kind of like, you can just like dump a whole lot of extra stuff for that to look up. Everyone's nodding their head because that was very clear. So if you had an object called thing, and it had a property called values with the string lol, if you passed in getValues thing, it would return lol, and you'll remember with thing, so thing.values, return values, that's lol. Sorry, we had to go back and forth. So if you passed in an empty array, suddenly your function's broken because it's not returning anything, it's returning a reference to a function. So what does that mean? And so this was a refresher on how scope lookup in with statements happens, right? You've got this like additional scope context, and then you have the prototype chain. I pirated this from a book called Effective JavaScript by my friend Dave Herman. You should buy it. Sorry, Dave. And so this was exactly the same thing, right? JavaScript added additional stuff to the array prototype. We added this values method, and it turned out bad things happened. So you had some code, which I think this was Sencha Touch. No love for Sencha Touch in the audience. So you've got this method passing in this thing called values, and eventually what happens is, this thing, it expects that values to not be a function. It expects it to be some kind of other object, and so things explode. And what we do here is, so this was a problem because browsers are already shipping this. And so the TC39 folks, what they did was they invented this thing called unscopables. And so this is like a hilarious hack where it says all these properties, copy within, entries, fill, find, keys, values. If you're within a with statement, ignore them, right? So it's basically like, don't look at these things for these 7 or 8 things. And that was the easiest way out of this problem because people really wanted array prototype values and keys and et cetera. So that's kind of another strategy is like if you can invent new technology, that's okay, and everything will work, and you kind of, it's like you're inventing technical debt. It's really great. Okay, so the DOM is my personal favorite thing ever. I love the DOM. So let's look at an example of a web page. So this is an app that works for, it gives you sushi restaurants in New York City, which super useful app if you live in New York City. And so you've probably seen websites like this, right? They're like, oh yeah, turn your phone, no big deal. That's kind of obnoxious, and you turn your phone, and it says, wait, I was at landscape, I always forget. This one's portrait, right? It's like, well, okay, that sucks. So something's wrong, right? And so looking through the code, you can see there's this orientation event listener that's looking for this window.orientation property saying, if it's not 0, call bad orientation. And I promise you that's the name of the method. They have opinions over at that website. Okay, so window orientation does not equal 0. We're going to do, if you look under your table, you've got 3D glasses. Thank you for looking. No, you don't. We're just going to pretend this is 3D. Okay, so we're going to access the JavaScript interpreters in our brains. This is a bit like if you go do a whiteboard interview. Undefined does not equal 0. Is that true or false? No one actually knows, right? It's true. You can double check in DevTools if you want. Undefined does not equal 0. True. Sorry, that's hard to read. Okay, so you remember this code. If true, call bad orientation, right? So that's problematic. You're always going to call bad orientation. And I guess that's sad. So what is window orientation? Does anyone know what spec that lives in? That was true at a point, right? So window orientation was this thing that Apple invented for the iPhone, and it was really cool. It allowed you to know which way your phone was pointing. Apple was really busy, and they forgot to write a spec. And so I did. And so this is kind of another solution. We'll talk about this in a second. But now, so sometimes when you've got non-standard stuff on the web and there's so much of it, all the browsers just have to implement that, reverse engineer it, and get some sucker to spec it. And so now this is like an interoperable, standardized thing. It works in all the mobile browsers. You can go ahead and use this. Okay, so let's move on to the CSS object model, the lesser of object models. We'll do another quiz. Okay, so vendor prefixes are a lot of fun. And so which of these work in shipping release browsers of Firefox, Edge, and Chrome? Safari also is implied there in Opera. So we've got lowercase WebKit transform, kind of bigger case WebKit transform, dashed WebKit transform, or just style transform. Any guesses? All of them and none. Norwegians are super extreme. It's all of them, right? Okay, so that's a little surprising, or maybe not. Okay, so but which one's correct, right? Like if browsers implement all that garbage, what does the spec say? The CSS object model spec, not the Mike Taylor wrote it in his basement spec. Guesses? 4 is definitely true, right? Like that's the standard way to access the style property on the CSS object, CSS declaration object, whatever the stupid interface is called. Guesses? Surprise, right? So this might be my fault, but the spec now says like these are proper ways to access those properties, right? You've got camel cased attribute. That's what the spec originally described. So that's number 2. So if you've ever written any code to like iterate over vendor prefixes, you know that like, oh yeah, I should start with a capital vendor prefix and then the property camel cased. And then when you tested it out in browsers, you're like, oh wait, no one actually does this the right way. Like WebKit implemented with lowercase, and Microsoft did its own thing. I think only Opera and Mozilla got that right. Okay, so but enough code is out there on the internet that you have to support it, otherwise things don't work. And then you have this dashed attribute, which is this number 3. People thought that was a great idea, and so we had to add support for that. You know, niche websites like Google Maps. Okay, so let's look at some CSS stuff, and I'm so sorry to make you look at CSS at a JavaScript conference. Trygve will issue refunds, I'm sure. Okay, so we remember we saw this OkCupid thing. If you had to guess Like, what is broken about the left-hand side? Sorry? Clipping? Okay, good guess. Any other? Yes, I didn't hear what you said. That's probably the right answer. It's something to do with like background position X and Y, I think. You know how like you can do sprites and you can position things using background position. There used to be a thing called background position X and Y that was only supported in some browsers. Now we all support them. So that was, and they had a WebKit prefix. Okay, so people made web pages, only wrote WebKit prefix CSS and forgot to include the unprefixed CSS. Nobody in this room ever did that, but these were other people, bad people. So on the left-hand side, like what's your visceral reaction? Like someone says, oh, hey, that's what our website looks like. What would you think is wrong there? You should all be thinking Flexbox, right? Like this was like 4 versions old Flexbox. Like the super duper old one only used WebKit prefixes, right? This one has unprefixed. So the reality there is browsers have to implement aliases to all the WebKit prefixed CSS to the unprefixed CSS. So Edge and Firefox do this. Blink and Safari will never be able to get rid of their prefixes. Like it's just not possible. And so that's kind of the solution there is you just alias the legacy garbage and call it a day. It's problematic though. So when we added support for WebKit prefixed gradients, someone reported they went to this super hot website, stripe.com. I don't know what they do, like sell basketballs maybe. Web payments is what they do, okay. So that text is not normal looking, right? So we implement the gradients, but what the heck? This is what this looks like in Chrome. It's really hard to see from back there, but there's this magical gradient, right? The color starts at kind of purple and ends at kind of pink, and it's really nice. You can see that easier now. That's the color of the text. And so looking at this, like what's the actual problem here? It turns out, so Firefox supported WebKit linear gradient, but then on line 4 we have this other thing, WebKit background clip text. I could ask you like what spec that's in, but you would know enough by now to be like, oh yeah, Apple forgot to write one. And so I did, and browsers implemented this. And so now that works, right? Like that's Firefox. And it's amazing. Like you see that text and you just want to process credit cards, right? Like that's really important for the web. WebKit text strokes is another thing like this. It allows you to come up with these super cool text effects, right? Where you've got, so this is a combination of WebKit text stroke and WebKit background clip text, right? So you've got the gradient text, but also you've got this nice typographic effect where you're just stroking the letter. You're not doing the fill. If you don't support that, it's not the end of the world. Sorry for the vertical shift. I'm really lazy. It's not the end of the world, right? Like this is graceful degradation or whatever the term of art is. But this is so much cooler. So anyways, I wrote the spec for that too. And so that's the other compatibility strategy is write the specs for the things that Apple forgot to do. In their defense, they're very busy. Selling like trillions of dollars worth of iPhones and stuff. So, okay. I just mentioned maybe some controversial stuff like, oh yeah, we just add support for WebKit prefixes in other web browsers. Does that make anybody uncomfortable? Raise your hand if you're upset visibly. Okay, like that row in particular is not happy. They're like 4 rows up. I'm gonna be going out that door. So at first, like this was not something that I was comfortable with either, and it took me some convincing to convince the people at Mozilla, like, hey, we should do this crazy thing. And then you remember back to the web juice, right? Sorry to make you remember that, but like what's important about the web? It's that people have access to information, experiences, content, right? Everything should look like that. Nothing should look like that on the left. And so the trick here is the one on the right is actually Firefox for Android today. It looks the same as it does in any WebKit-based mobile browser, and so that's what's important. I just like this picture, so we're just going to look at that. Okay, so you don't have to be super sad, right? So, like I said, I work on a standard through the What Working Group called the Compatibility Standard, and that's where we track. We've kind of just like the web standards community, not just me, right? Other people in other browsers work on this. We've decided that like these APIs are part of the web. They just are APIs with really crappy names, right? They just start with WebKit. It's just a poor name, but they're worth working on. It's not a ton of stuff, so that's great. And there's other stuff that other people have worked on through the WCAG, which is, I forget what that stands for, WICG. So this was like the non-standard Chrome file directory API that browsers have to implement now because important websites started to rely on it. Okay, so another thing we do sometimes, but very infrequently, is remove things from the browser. So show modal dialog, raise your hand if you've ever used that. Nobody, so that's cool. So yeah, one guy in the back, right? If you don't know what it is, that's great because it doesn't work anymore. And we only broke one web page. So Outlook Web App 2010, you can't add attachments to your emails anymore. Sorry about that. Arguably, it's 2017, and you have different problems. App cache is something that still works in the browser, but we want to remove that one day, so you should migrate to service workers so we can not break the web for everyone. And isIndex is a crazy old HTML element that was recently removed from the spec and from browsers. And anyway, so now that you're kind of intimate with the web compatibility problem and you're really fired up and motivated, you want to know what you can do to make this problem better or go away. We should be reading standards, right? So is anyone familiar with W3C? No, so W3C schools? Yeah, it's a fine Norwegian company. That's not the website I'm talking about. Find standards, What Working Group, W3C, read them. You should be testing your websites in other browsers. I know that's revolutionary. I don't remember why this guy's here. Pre-release channels are super important, and nowadays you have access to all of the big ones, right? You've got Dev Edition or Nightly, Edge Insider Preview, Safari Tech Preview, et cetera, Chrome Canary, and you can download these all. And my advice is just like every once in a while open your production app in Chrome Canary, for example, so you'll know that like, oh, in 3 months, shit's broken, right? And so you can fix it. Report bugs. Has anyone here ever reported a bug to a web browser? Like to WebKit, to Firefox? It's not very many of you. Has anyone ever felt like they found a browser bug? Probably a lot more. But sometimes you think, you're like, I don't know, my code maybe just, I'm doing it wrong. They're really busy and smart, and they're going to make fun of me. That's not true. We're not that smart. But now there's public bug trackers for everyone. Sadly, the Opera one is a black hole, but you can still report bugs to them. You just can't see what happens after there. Feel free to just like file bugs, and if they get closed as won't fix or invalid, that's okay, right? You don't have to feel sad, but you might help the browser vendors understand like, oh, we did a bad thing by fixing this bug or implementing this feature, and we're going to break your website, and your users are going to think you did it, and so we can catch that earlier. I also work on this website. My team does webcompat.com, and it's basically like a honeypot for broken web pages. And so you can just like report bugs there, and we'll try to figure out what's up and get those to the right people. Or if you're just want like an intimate bug reporting experience, you can email me, and it won't be weird, I promise. And I'll even read it. So that's it. I'm Mike Taylor on Twitter. Thank you very much.
I love the casual walk over to the couch, like, this is so normal, and ignore all these people.
Can't actually see them. There's a light.
That's fine. That was a great talk.
Thanks.
You mentioned plumbers of the web. Do you ever actually feel like a secret agent, like you're doing these horrible, dirty things in the dark, and no one knows the blood that has been spilled to defend their ability to type like blink and have the text blink?
I was
Not
explaining.
that anymore, but
I don't feel that way. I was explaining to someone earlier, like I'm pretty dead inside after looking at. You look at enough darkness over the years, and you're kind of just like. I think that's how CIA agents end up as well. They're like waterboarding, no big deal.
I was going to ask you if you felt cynical. I think I don't need to anymore.
Yeah, sorry, that's like a really insensitive. Like torture is not okay. To be clear.
Yeah. I got a couple questions that were, what is your favorite and least favorite spec?
That's a good question. So my favorite spec, I think the HTML spec is really good. There's some cool people working on it. A lot of people work on it, but my friend's colleague and Anna and others work on that, and they're amazing. So it's really readable. And if it's not, you can file bugs and say like, I don't understand this, and they'll contribute. They'll encourage you to submit a pull request, and they'll help you through that, which is amazing.
That's cool.
Do
they accept pull requests to bring back the blink tag? Is that on the table?
Possibly, you know, if you can get like if you can get Facebook to depend on it, it'll be back. If anyone here works at Facebook, don't do that. Least favorite spec, probably the full screen API, just because it's a nightmare.
I heard some groans.
Yeah, it's no like the spec writers have done a good job. There's just like this history and legacy of, you know, like Mozilla had one version, WebKit/Blink had another version, and then people went out and made websites, and then they're like, let's make a new version that's unprefixed. And right now, nobody can ship the unprefixed version because that breaks so much stuff. So it's kind of a mess.
Okay. So, I mean, a theme of your talk is you can't just break stuff, but in some platforms you can, right? Like Python 3, they just changed how it worked, and they can do that. And server-side languages, they do backwards incompatible changes all the time. Do you ever look at that and get jealous and think, like, I wish I could just fix all this stuff and not have to worry about someone's website from 2005?
So that's a good question. No, I don't. I still use Python 2.7. Is anyone here actually on Python 3.5? No, nobody is. So I think, like, reality is things will break. Eventually, you know, you have to consider, like, what's important for the web. Like, ergonomics are super important. Top websites are more important than MikeTaylor.com, unfortunately. And so there's a balancing act there, but I think, you know, like the promise, I used to work at Opera up the road years ago, and our colleague Ola, he had a sign on his door. He had like a cave, and it said, "All sites must work," right? And that's a pretty powerful promise, I think. And so that's kind of the magic of the web, right? You have a URL, you can share it, the content will work. It might, you know, maybe in 20 years it might not look amazing, right? Like even if all the CSS is gone, like the content is there, and that's important. That gets trickier, you know, as we do more and more client-side applications, for example, right? Like if you throw a random type error because you broke something, like your whole page might be hosed. But yeah, I'm not jealous yet.
Okay, in time maybe.
Yeah.
Awesome. Well, thank you so much for your talk.
Thank you.
Please give him another round of applause. Thanks, Mike. Our next speaker is Steve Kinney. He is a senior front-end engineer at SendGrid. He is the lead organizer of Dinosaur.js, a fantastic conference that you should go to after Web Rebels. And he's here to talk to us about JavaScript style sheets. Please give him a round of applause.
All right. As you can see from this introductory slide, this is a very serious and important talk. We're going to talk about three things. We talk about the 1990s, We're going to talk about JavaScript, and we're going to talk about style sheets. I hope I've covered that all on this slide. So yeah, my name is Steve. This is my Twitter. I currently work at SendGrid. I work on a client for creating marketing emails, which is super cool. You build this big WYSIWYG interface with like React and all that kind of fun stuff, and then you output stuff that would make Mike cringe, because you have to support Outlook 2007. And if you've ever thought like, I remember dealing with Internet Explorer, that was bad. Like Outlook is basically like hold my beer, because it uses Microsoft Word's rendering engine. So that's a lot of fun. I know a lot about Outlook conditional tags. If that's something you want to, like, you've been like searching your soul for someone to like talk to about this, we can do that. And as James mentioned, I also run Dinosaur.js, another JSConf family conference. So speaking of this conference, is really like amazing to me because Web Rebels is one of the conferences that Dinosaur is kind of like based off of as one of its role models. So it's super exciting for me to be here. Because previously I was just stealing ideas without ever being around for them. And I'm also working on a book. So we're going to talk about the year 1996. One of the best parts about doing a talk on the 90s is like every like keynote and PowerPoint transition you were told you can't use, you can use now. So get ready for that. But I do want to get us in the right like mental headspace for this so that we can kind of like remember what it was like. The modern phone at the time did not have a headphone jack. We walked around trying to collect digital pets. We spent time neglecting digital pets. We cloned a sheep. We cloned the Beatles. We drank this. At the time, I was 12, and I was working on a Mortal Kombat website where you can go and like read about all the fun moves that you can do to create violence that makes parents cringe. And I couldn't find the site on GeoCities, but I do remember that it was loaded with animated GIFs for no particularly good reason. It was built with zero concern for accessibility. It took like 3 minutes to download all the assets, and it auto-played obnoxious media files. So effectively, it was a 2017 web page. This is very much what it looked like. This is a Doom one, so if you just like reimagine all the Doom with Mortal Kombat, that's effectively what it was. And it was not out of style for the time. There were other sites that kind of very similar. Yeah. Yes, Bobby. Yes, you do. And I see that you have an auto-playing MIDI file. Good job. And the markup was always fun because we use inline styles everywhere as HTML attributes. And so you would put everything in there. If you needed to like change another color, you'd go ahead and like go to the sub element, right, and do each one. And you're like, ha ha ha, the marquee tag. That's very funny. It still works in Chrome. So yeah, if nothing else from this talk, you learned that that's still a thing that you can do. You shouldn't do it, but you could. And like, you know, I wrote the proposal for this talk before I started working at SendGrid. So just last week, I had to write this as markup for an HTML email. So I'm now like, I feel like I karmically did this to myself. You know, you might ask, you know, a Mortal Kombat website, like, why does the world need more than one Mortal Kombat website with these fatalities and friendships in them? And that's a really good question. One, I was 12, give me a break. 2, that's off topic. We're talking about JavaScript style sheets. Try to focus. And 3, just keep that in mind next time you're going to write a medium think piece about JavaScript fatigue. All right, so we hit about, at one point I had finally visited the site 100 times. I know that because the hit counter went to 100 times. Figure my mother was one of those, but the other 99 were likely me, which meant it was time for a redesign. And going through and changing all the styles on a page can only best be described with stock photography. The only saving grace is that I did have frames. So you ideally a frame was really cool. It's like this completely isolated reusable piece of user interface. We should try that these days. Also works in Chrome. So style sheets. Style sheets were actually present in the original web browser as built by Sir Tim Berners-Lee. You might know him as web developer. Viola was a browser that shipped, which actually gave support for having custom style sheets. Every browser, almost every browser, we'll get to that in a second, had support for an idea of style sheets, but there was no necessary syntax to write style sheets, right? But the concept of a style sheet has always been there, with one noticeable omission. In fact, to this topic, Mark Andreessen wrote, "In fact, it's been a constant source of delight for me over the past year to continually tell hordes, literally, of people who want to, strap yourself in, here it comes, control what their documents look like in ways that be trivial in text, Word, or every other common text processing environment." He likes to tell them, sorry, you're screwed. And the idea for a style sheet would be that the browser could have some impact on what a page would look like, but then the user could also provide a style sheet until someone came in with a reset CSS and blew it all away. This emoji, by the way, in case you're wondering, is called disappointed but relieved. That is the official name of it. You can see Netscape had support for kind of styling pages based on user preference. Firefox still does today. Safari will let you actually upload an entire style sheet that will be your user preferences for what the page should look like. It wasn't until later that a third party wanted to get involved in what pages should look like. This was the author of the page itself. And this was to questionable effect. This is a page that I built in, I think, 2005. So, we let authors do it. That doesn't mean all of them had good taste. You can see some tables, lots of textures. I don't even know what's happening with that sidebar over there. So in order for that to happen, we have to have some kind of syntax for writing style sheets. Right? And there was a bunch of different ways of going about this. We're only going to talk about two of them. We'll talk about CSS and JavaScript style sheets. JavaScript style sheets weren't around long enough to get a logo, so I made one. Well, basically, I took a really bad JavaScript logo and then added style sheets and Comic Sans to the bottom. And it only felt right. This is not the official CSS logo, but this felt appropriate to pick the worst one that I could find. JavaScript style sheets are going to be the one we kind of focus on, shipped in Netscape Navigator 4.0. And what we're going to do is we're going to do a little bit of live coding. Cool. Let's go ahead and mirror some displays. I got a modern web browser over here. This is just an HTML page. We can take a look at it together. There's not a lot happening here. Nope. We can see that we've got one thing to notice is that we pull in. It's a link to a style sheet, but it's style.js instead of style.css. Other fun things is we got H1. We got some classes on it. Nothing really to see here. What you might normally expect an HTML page. And this is what it looks like with no styling. Cool. So let's go ahead and let's try something out. All right, so this is a syntax for JavaScript style sheets. You can see we have the document, our good friend, and it's got a tags property, and we have all of the different tags that are supported in the browser at that point. And then we've got the color property, which is exactly the same as the CSS color property. So let's go ahead and save that. And we can see that it styles the page. Woo! All right. Cool. We can also change the font size and all the normal stuff that you might expect. Go ahead and try that out. All right. The font size is now bigger. We have some options there, though. We can actually just give it an integer. That will give us the same effect as well. In fact, document, because it's globally available, we can omit that. So this syntax is getting slightly smaller, slightly easier to work with as we go on. We can also set variables, right? Because it's JavaScript. We can say, the color is blue. We can go ahead and then use that multiple places. So we can set and you can see there's also ways of doing classes here, right? So we've got document.classes. We can go ahead and this is a class in our HTML called first, which is not super semantic, but it's cool. And we go ahead and get all the paragraph tags that have that class on it. The other option is you could go ahead and change this to any, and that will also get all the ones with that class, right? So some very similar ideas to CSS at this point. Let's try it out a little more. We can try different things. We can pull them in there. We have IDs now as well. Grab something with the ID of main, and we can style that. Let's go take a look. You can see this page is getting better and better looking as time goes on. I'm really proud of it. We can even use conditionals. Because who doesn't like a little bit of indeterminism in how they style their web page? So here we will get a random number between 0 and 1. We'll round it so that we either get 0, which happens to be falsy, or 1, which is definitely truthy. And if it is true, we will kind of turn the background color to black as he refreshes it enough times to get it to work. Other fun facts is you don't get errors in this version of Netscape, so if something doesn't work, you're kind of out of luck. There it is. All right. Never know what you're going to get each time. In fact, we can add a little bit of user interactivity here, where we can actually ask the user if they would like to be in dark mode or not. This was dark mode was a thing in 2005 for 3 months, where people thought it based on the time it'd be cool to change it to different modes. I did that. We go ahead and refresh that, and you can see hey, enable dark mode. Okay. And now I'm in dark mode, right? So we can actually get a certain amount of interactivity from the user that you can't really do in CSS, which is kind of cool. Also, your style sheets can now throw alerts. What could be even better than that? In fact, luckily, Mike taught us about the with tag, so we can or the with keyword, so we can go ahead and use that to kind of shorten things. So we're starting to get something that looks a little bit like CSS at this point, right? We're starting to get the general feel of it. We can kind of remove some of that boilerplate, Mike is literally twitching right now. Cool. There was also this contextual function. Contextual basically gave us some amount of getting a little bit more specific with selectors. So this will be, okay, find something has both the class of second is a paragraph and has also the class important, right? So this is a way to combine. We can do this in CSS now. This is a way to combine multiple selectors in order to have more fun. Cool. The really cool thing that we could have done is we can start to we would have been able to polyfill things, right? We have the full power. We have loops. We have conditionals. We have functions. We can go ahead and be able to dynamically figure out okay, we want to create a viewport width primitive. We can do that with a function. We want to go ahead and figure out how to vendor prefix things on the fly. We could do that as well because we have the full language. The other thing that's kind of cool is we can also look at the window object, right? Here we can take a look at this width. We can say, hey, if it's less than 600, we're actually going to pretend we have some amount of responsive design, which is still kind of hard to implement. Let's go ahead and fix I tried to be a cheater, and some of that didn't work. Cool. All right, so here it is. It is greater than 600 pixels, so it ends up being blue. And what's interesting is, as we shrink to less than 600 pixels, the style sheet is reevaluated every time, right? So we could go ahead and, at this point, change the layout of the page. All right. There's more. Yay. We don't have screen. Thanks, everyone. I should pull the mic move of unplug it and plug it back in. Can't hurt, right? Come on. Yay. And there was a lot of excitement around this idea of being able to programmatically adjust our styles, right? I think a big thing with JSSS is that a value can change on the fly because JSSS is an extension of JavaScript. Thus, within JavaScript, you could change the color or font size of an element based on some amount of user input. You can imagine like a form that if everything is invalid, you could change the way those styles are expressed based on what's going on there. You couldn't really do a lot of stuff because even in this version of Netscape 4.8, there were the methods to adjust the DOM weren't there yet. You couldn't query the DOM and like change nodes or anything along those lines. So a lot of the potential wasn't like fully met yet, but we can begin to imagine like knowing how we know the next 20 years is going to go on the web, some of the stuff that we would have been able to do with this technology. We're also going to do a little bit of fake coding. There was a spec. Not everything in the spec got implemented. So there were a few things that, despite it like being like, hey, JavaScript style sheets do this, they didn't. So we'll talk about some of those. One of which could have been really cool is this thing of dynamic evaluation. And here's an example of that. You might be wondering, where's the function keyword? I don't know. I copied this from the spec. It didn't work with the function keyword. It didn't work without. So we can only guess as to the efficacy of this code. And here we have a function that basically, depending on certain other rules on this style, will go ahead and like determine different things. And you can see that we can just call it as a function with this apply at the end. So you can have one rule that, based on the other properties of that style, would express itself differently. But don't worry, specificity was still a thing. One of the reasons for this is, and one of the reasons that if you were to sit down and start writing JavaScript style sheets right now, that you could go and just like use all of your CSS knowledge, is because when it shipped in Netscape, it actually just shelled out to CSS. And so they kind of like had the same API. So CSS, I don't want to ruin how this story ends for you, but CSS kind of won. CSS, which was kind of pushed by Microsoft at the time, was accepted as a standard by the W3C. JavaScript style sheets did not make it that far. So if you were writing a web page for Netscape, you could either write CSS or JavaScript style sheets. But if you wanted to write that same web page for Internet Explorer, you could only use CSS. So anyone want to take a lucky guess what most people decided to do? They wrote CSS. And JavaScript style sheets were never fully accepted as a standard. And they lingered on through the rest of the Netscape 4.0 series and were removed by the time 6.0 shipped in 2000. And I think that there were a lot of missed opportunities with some of the ideas in JavaScript style sheets. And it's, you can look at them and go like, well, there's all these things I can do with CSS now that, you showed me, there was nothing I saw in JavaScript style sheets that I could do back in 1996. But let's keep in mind that CSS couldn't do it then either, so that's not totally fair. Another thing that's not fair is for me to project what JavaScript style sheets would have been able to do in 2017 and across the 20 years that followed and just make up realities. So I'm going to do that. I think it would have been cool with JavaScript style sheets, to be able to use stuff like Modernizer to see like, okay, what does this browser support, and kind of implement the fallbacks right there. And like, okay, we don't support border radius. This is what we want to do in this case, so on and so forth. Right? We would have had the ability to implement polyfills. You can imagine stuff like asynchronously loading code would have theoretically been easier in 2017 if we could like use async await to pull in additional styling. This is all made up. Even stuff like form validation, we could theoretically change the way the form looks based, if we had all of our DOM querying methods and stuff along those lines. So a lot of these ideas, you're like, well, I can do a lot of those things with the tools I have today. Like, yeah, totally. And I think it's interesting to think about this in another way of, well, like, what are the things we can't even think of that we would have been able to do if we had a full power of a programming language defining the way that we style our web applications. And a lot of these ideas of, hey, functions and variables and conditionals have endured, right? We've seen them in, kind of take other shapes. We've seen them in Sass and less. We've seen that CSS4 even has support for variables and custom properties. But on the kind of Sass and less point, there is a little bit of a distinction, right? All of this happens at compile time, right? Which means if we had a function that generated a random color, it would totally be random when we built that CSS file. And that would be it, right? After that, it is like in the CSS file. Like whatever Sass function or less function you have, it's still going to be in there. We have no ability to kind of have that, what we saw with the responsive design mode, where we could like take a look at the way the DOM was, the structure of our document right then and there, and make styling decisions based on it. And I would argue that one of the spiritual successors to JavaScript style sheets was something along the lines of jQuery, where we could take a look, we could have, all right, how many columns are there? What is the size of the window right now? And make different decisions based on that. But, Mike mentioned before the CSS object model, right? And luckily, we got a slight introduction to it. The CSS object model is basically an object representation of all the styles applied to the page. And here are some of the basic structure of it. You can open up your browser right now and type document.stylesheets, and you'll get this kind of array-like structure that's going to be all the style sheets loaded into the page. Each style sheet will have a set of rules, and you can insert rules and delete rules and modify them, stuff along those lines. So this almost seems like the kind of holy grail that we're looking for about being able to kind of get insight into our pages and modify it based on the structure of the HTML document. And in fact, you can do some cool stuff. You can dynamically, for instance, change the color of a page, right, at runtime. Very cool. And this is what that code looks like. We can go in, we grab all the style sheets, we grab what we hope is the first style sheet is the one we want. We go grab its rules, we assume it's the first rule. We go grab its style, and we can kind of like go in there and like get that style. We can manipulate it and we can change it, but you can see that this is not particularly like a single change to that CSS file is going to literally break all my code, right? So here we're actually doing like form validation. And in the DOM, we've got a lot of like interesting ways to go about this. We can't actually, like, anything that doesn't make it into the CSS object model, we have no access to, right? Anything that it doesn't understand gets lost and it just drops, right? We have the ability to parse DOM, but we don't have the ability to actually parse the document itself unless we bring in something like PostCSS as a client-side library, and then we could theoretically grab the style sheet and parse and all that stuff. But we kind of rely on this otherwise. And the CSS object module, like I said, drops anything it doesn't understand, which is like me. And like it's hard to navigate, it's underspecified, it doesn't give us everything that we want. And it kind of represents a little bit of the struggle of building for the web. We've taken this document viewer from the 90s, and what we've tried to do is turn it into the world's most widely distributed application platform, right? And there have been some bumps along the way. And in JavaScript, like we've kind of dealt with it as our craft has evolved, right? We've started for me, a very similar thing, which is we start to work around the problem. Then we kind of build better tools, and then we eventually like fix the problem. And there's a whole bunch of stuff that like you needed to know. I used to teach JavaScript for a living. It's interesting that like stuff like object.hasOwnProperty is not a thing that you need as much as you used to, right? But like all of a sudden you'd be iterating up prototypes, and that was a bunch of fun. Also, it doesn't exist in Netscape Navigator 4.8. And so there's all these things that we kind of worked around. We eventually like came up with solutions for a lot of these, whether it's just catching these before we commit them. We're using something like ESLint, making async a little more clearer with promises. We theoretically have modules nowadays, and stuff along those lines, right? And so this is kind of, again, going to that process of doing things the platform was never meant to do, working around the hard parts, and just like kind of like a code of honor, like, oh, we don't use double equal sign for like, all X, Y, and Z reason. It just becomes the way we live our lives as like JavaScript developers. And then we try to automate those things, whether it be linting tools or build tools, and eventually we get around to like improving the platform. And we kind of have this new way of building applications these days where we try to break everything up into small components. These components are isolated. We can pass in everything that they need. We can give, here is the state of the world to the application, and this is the UI that should be rendered as a result. And one of the things, as we've been, and this is like kind of, in a lot of ways, changed the way that we go about building these websites, but it's had us butt heads with an old friend. Right, which brings to the kind of refrain that CSS is broken. And like, CSS has got some problems, right? All the styles in the global scope. Good luck figuring out if something actually uses that style. Good luck to see if your code uses a style that's actually in your style sheet, right? There are some definite difficulties the way that we build user interfaces now and what CSS brings to the table. But I'm always like skeptical of the CSS is broken thing. This is like a great little thing by Nicole Sullivan, which it's like I've noticed that everyone who is very good at CSS doesn't seem to fully share the "it's broken" feeling that I think I initially felt. And preparing for this talk and thinking a lot about the history of the platform, it started to make me consider where have I seen this pattern before. And I think we need to ask ourselves whether or not we are falling into the same trap. Because clearly, according to the internet, not too long ago, you cannot build applications in JavaScript. So yeah, I'm not sure that I fully, just because it hasn't been too long ago that JavaScript was the one where let's just write Ruby and compile it down to JavaScript and everything will be great. JavaScript is not dead. Applications, I'm told, have been built in it. And even some of these have been revised since then. And there were a lot of experiments along the way. And we were able to try out a bunch of ideas and take the best parts of those ideas and pull them into the language. So that's what I think that we should do. And because we pulled them into the platform itself, we're able to share those across the frameworks. It doesn't matter if you're an Angular developer, an Ember developer, or a React developer, right? We've improved the platform. We've improved the language. We have APIs that didn't exist long ago, and we all get to kind of benefit from those rather than working on them in silos. So I'm not convinced that we need to throw out CSS in order to be able to improve the web platform. And CSS it has its rough edges, two words, clear fix. But who amongst us doesn't? And there are a lot of cool things that CSS brings to the table, right? This is CSS Zen Garden, where people get this HTML page, and based on the CSS that they write, can dramatically change the way that the page looks and works. And this idea of the separation, you wouldn't be able to do that with the same markup if it was directly tied to every piece of that page. At SendGrid, we still need style sheets, right? We have a Backbone Marionette app as our dashboard. We have a React app to build the marketing campaigns. We have a WordPress site for the main page itself, right? Having a solution tied to a framework doesn't really work for us. Which brings us back to this idea of I think a lot of the solutions that we have to building user interfaces and styling them right now are super interesting and really cool, right? But I think about the process that we went through with JavaScript. And I fear that what we'll end up with is a bunch of really awesome solutions that are each siloed, so that if you're building an Ember app, you need a different solution than if you're building a React app, so on and so forth. And a lot of the problems with CSS we currently can solve with build tools. Right? You have tools in PostCSS like StyleLint, which will find all the things that you probably shouldn't be doing and alert you to them, so that you can then disable the linter for that line and commit. We can make sure that we're not changing styles again, if we've already defined them, and kind of catch those common mistakes. We can begin to figure out, can we build custom class names so that they are scoped and we're not worrying about one class stepping over another class. In fact, in the platform itself, we are kind of moving towards solving some of these problems that ideally, once they're baked into the platform, we'll be able to share across every technology built on top of it. But I think one of the really cool things is this idea of compile time and runtime. And I think a lot about how we get from here to there, right? We've seen the JavaScript platform improve dramatically over the last few years. I think a lot about like my kind of like pet theory and why that happens, stuff like the extensible web manifesto, this idea that we provide low-level APIs and we let developers be able to play with them like immediately, right? Async await gets into the TC39 spec and like there's a Babel plugin for it like 2 days later, versus something like CSS Grid where you can wait a really long time or waiting for like Flexbox or anything along those lines. We'll talk about why there's a difference between those two in a second. And some of the major parts are explaining existing features and kind of giving access to them so that you have the ability to kind of have some introspection in there. And being able to polyfill future features. And we kind of talked about library authors being able to like, there's an idea for a feature, let's try it out, let's figure out what the developer ergonomics are. And so we know that JavaScript goes through this process of being a straw man, kind of getting out into the community, having developers play with it, taking in feedback, and eventually becoming part of the spec. How would we pull something like this off with CSS? There's actually some really cool projects around this. There's one project at W3C called Houdini. All right, and Houdini's basic goal is right now, this is basically what we have access to. The dark blue, like we know that we can manipulate the DOM. And we can have some introspection in there, right? We saw there's some amount of wiggle room with the CSS object model. The rest of it is completely opaque to us. We have no idea like what's going on in there, and like at runtime we have no introspection to it. We can't see as like application developers. So the goal of Houdini is to kind of give us those insights and kind of give us access to each part of the page rendering process. And so for stuff like the CSS typed object model, right? That's an improvement on top of the object model where theoretically we would be able to do a lot of those things that right now we're almost able to do and have a lot more insight into exactly how our applications are getting styled. So JavaScript style sheets were short-lived. There are some ideas from JavaScript style sheets that we've seen through Sass, through Less, through post-CSS that have endured over the decades between then and now. And I think as application developers, we're solving problems with the best tools that we have. But I think that there's definitely an exciting possibility to have better tools. And so what a lot of this comes down to is us. We need to be really excited about these ideas. We need to push for them, right? Because there can be experiments, there can be different approaches, but it's kind of like a chicken or the egg problem, right? Browsers are going to implement things that developers are excited about, but developers kind of also need to get excited about things that could be coming down the pike, right? And we need to get it kind of involved in the process. And yeah, our platform has limitations, but we've done a lot with it over the last few decades, and we've built an amazing application platform. And I'm really excited about taking the tools that we have and figuring out how to take the next steps forward into building the tools that we want. Cool. Thank you very much.
Hello. Hello. I hope that the walk from the table here gets less awkward as I do this more. I'm like, what do I do with my hands?
I think you'll eventually just own it more.
Yeah.
It'll become part of who you are.
Maybe I'll just sit on the couch the whole time.
You could just sit and awkward, especially now that I'm done. You could totally sit and just awkwardly,
Now that
maybe
you're
put your
done.
feet up and
yeah.
take a look. Yeah.
You mentioned dark mode and implementing that. I thought dark mode was when you did HTML emails, you went into a dark mode personally.
Yeah, it's
to your
definitely,
dark place.
it's more a sad mode.
Yeah.
Or a little bit of frustrated mode. Because even every version of Outlook doesn't use the same rendering engine. So you fix something in 2007, it breaks in 2013.
Darkness.
Darkness.
So you kind of talked about the evolution of JavaScript and how the ecosystem has evolved a lot and helped us out as developers, and suggested some ways that we could apply some of those same things to CSS. Is there anything that you look at in CSS and think, this works really well, how could we apply this stuff to JavaScript? Does that kind of make sense?
Yeah, I think one of the interesting things is looking at how the two platforms came at things from different angles, right? So you look at CSS and the way we've always processed it, right? And so you do it at compile time, right? And you have no insight at runtime. JavaScript, you load up the JavaScript file, and you have all this introspection at runtime. And now we're saying like, hey, what if we ran something through like prepack or Babel and like did all this stuff at compile time? And we kind of see like the answer might be both approaches are good, let's use both of them, but they both started from different ends of the spectrum, and I think they're starting to, I know JavaScript is taking a lot more of the approach that I think a lot of CSS build tools took, and I think it would be really interesting if CSS began to take from the other side as well.
So that slide that you showed with the potential for more APIs into CSS, that stuff is a spec already, right?
It is like actively being worked on, right? So there's actually a GitHub repo for kind of all the work in progress, and you kind of see there's a few things. There are like specs for the CSS object model, and this idea of like worklets where you can have like kind of like custom behavior.
Worklets is the cutest name for a technical
really cute.
thing.
It's
I
really
like
cute.
That. Yeah, it sounds like an animal.
Like who wouldn't want to work with a service worklet?
A service worklet.
Like it would be so cute.
It's adorable. I guess when can I email Mike about those? That's my real question. Like,
I think we can do it right now.
Okay. You kind of talked about, you like delicately danced around the CSS in JavaScript topic. I'd like to give you a chance to offend people by saying what you think about it more explicitly.
Yeah, it's interesting. Like on one hand, like the idea of having CSS isolated components is something I've been like super interested in since I first heard about it like a few years ago. There is a little bit where I think about it of the times we tried like we're going to replace JavaScript with this, that, and the other thing, which is these are the tools that we have to work with right now. This is the best possible thing that we can do. But there's a little part of me that when I look at a lot of the syntax and a lot of the approaches, I'm like, the ideas are really great, but like, is this really the way that we want to live with the for the next 5, 10, 15 years? Like, does this feel right? It's what we have to do to pull off this effect that we really want as we build our user interfaces. But it doesn't strike me as like this is the API that I really want. This is the way that building apps is going to make me permanently happy for the next few years.
Sure, that makes sense. How much research did you do on like the Internet Archive and
a lot.
The Wayback Machine?
There's one, and I lost the text font. I couldn't re-find it. But there was one person in 1995 or 96 who was incredibly excited about both style sheet languages because they thought, soon I will be able to have print-like layouts and lay things out in a grid. And I'm like, I'm hoping they weren't holding their breath.
But now they can.
Now they can. 20 years later, vindicated.
They're a visionary.
Yeah, ahead of their time.
That's awesome. Well, so you answered a better question. I was just wondering about like Bob's website type of stuff.
Yeah, a lot of that. Like that was the less practical research.
Yeah.
There was the I'm very caffeinated research, which is like Internet Archive, reading all the discussion threads about CSS and JavaScript style sheets.
Yeah.
And then there is the coffee has worn off, I'm very tired now research, which was 90s memes. And trying to find very small 800 by 600 pixel screenshots of websites that I was too proud to blow up to make look any bigger.
I feel like browsing like old school GeoCities is kind of like the YouTube loop of the 90s.
Yeah.
Like you just click WebRing links and you end up at Bob's webpage.
Yeah.
Get a feel for who he was.
I wish I could, like I only found that screenshot. I wish I could like scroll down. Like, if I had one wish, I want to know more about Bob. He has a website. I don't think the story ends there. Right? I think there's more. And I don't know if the other one. I think it was like the red one is somewhere. The first line before it goes down is like diviner of serpents or something like that. Like I want to know more.
Yeah.
Like what's next? Where does this go? Yeah.
Yeah. Cool. Well, thank you so much for your talk. I really enjoyed it.
Thanks.
Please give a round of applause to Steve.
Thank you.
So we have a break coming up, but I have a couple of announcements before the break. First of all, does the Wi-Fi work for all of you? It's working pretty well, right? Can we clap for the Wi-Fi? That's amazing. Good job to whoever's doing that. There are lunch groups, or dinner groups, sorry, not lunch groups. If you're going to be around here on Friday and you don't have any plans, there are signups. Where are the signups again?
Send it on email.
In an email, yes. Check your email, and you'll be able to sign up for just a random dinner group. I think you can pick the kind of food that you want, but you don't know where you're going, you don't know who you're going with. You just want to have a cool experience with fun people who are around you right now. So check your email, sign up for that. The signups close by lunchtime, so do it during the break. Don't do it during the talks. Watch the talks. But check your email and do that. It'll be really fun. It was great last year. I also forgot to announce where the bathrooms are. That way. Buy the t-shirts. And then the break will go until 11, so we'll see you back then. Hello. Hello, hello. Hello, how was the break? Was it good? Excellent. I'm glad you all made it back in. We have some great talks, and then we have great lunch, so glad you're here. Our first talk after the break is by Magnus Dahlen. Is that how I pronounce it? Sorry for your messing up your language. He's here to talk to us about Vue, and give him a round of applause.
Vue, as you understand, with my talk, A Room with a View. Just gonna do a quick intro about myself. My name is Magnus Dahlen, if you say it in Norwegian, but Dahlen is good enough. I'm also a consultant here in Oslo. I work for Iterate, which is a small consultancy firm here in Oslo, and I'm currently stationed at Cisco, where I learned about Vue, or actually got my first experience. I'm also out on parental leave, so I just snuck out to get this talk. So, what we're here to talk about? Talk about Vue.js, and I love the name because it's you can do so many puns. So I started to just caption what my Vue were when I first learned about Vue, and I thought, I'm looking into a forest, a bog, not that cool. So, but my colleagues said that this is a good view here in Oslo. You can sit watching into a brick wall, or on the other side of the building you see this traffic machine. Not that cool. So that's not any better. So what sparked my and our pursuit for a Vue? So I work at Cisco, or a consultant at Cisco. I'm working on delivering a web whiteboard, online web whiteboard for Cisco Spark, which is this, which is a collaboration tool, chat, video conferencing, all that. They're also selling a big pad called a Sparkboard, where you can do whiteboarding on real time, which can be, you see the pointing to that there. So anyway, our problem were that this app is integrated all over the place, Windows, desktop, iOS, Android, every tablet or you can think of, and we're making a JavaScript application. So, and unfortunately, it runs through a web views or iframes, not probably the best way today. So we only delivered the online or the web whiteboard. We didn't actually do the integration and stuff. So we needed a way to test real-time messaging between this whiteboard app and the interaction between them. So we needed to make our own client, or at least our own client, not a fake one, a real client. So why did we choose Vue to do that? And the answer is more like, why not? This started as a pretty low-risk application, and it's also today in production in Cisco, but only for developers and testers internally to actually see how the web whiteboard works. And first, I thought, let's just do it with React. I have a lot of previous experience with React. I'm very lazy. I'm fear of the unknown and all that. So I suggested we just do it with React. We do it fast, quickly. But my colleague, which privacy issues couldn't get a picture of, suggested that we live a little, expand our JS minds. So he heard about Vue, which was supposed to be lightweight, quick, and easy to work with. So okay, I agreed. Let's try it. So quickly I scanned the web to see if this lightweight proposal was correct. And I found a lot of benchmarks, especially this one from Stefan Kraus, where actually this one's from January, a new one after we started working with Vue. But Vue here is doing quite well on different type of benchmarks, inserting, deletion, alterations of DOM rows, in both keyed and non-keyed tests. But React and Angular also are pretty quick here as well. But I didn't add in the slide there, but the memory allocation for Angular and React is quite much bigger than Vue. So that's the main goodness for Vue at the moment, or at least from the January tests. So also another thing, quick stats, is that Angular and React are quite bigger than Vue, Angular in particular, which is pretty important when you're trying to keep your application small. And for our part, we want to keep our application small, so the load time on mobile and stuff like that would be less big. But maybe it's not, you don't want to compare them to Angular and React since they're seen as much bigger or like stable frameworks now. Maybe we should compare them to Preact and Inferno, which are smaller, lightweight frameworks. And they do well in that test as well. We can see that Vue is faring quite well against both Preact and Inferno. And the same with Preact and Inferno, they also allocate a lot less memory on your browser, which is something, it's a good thing. But they have their drawbacks, but someone will talk about them someday. Anyway, so back to our first day. Again, I was lazy, a little reluctant. I was whining to my colleague to start, do I have to go to the README, learning Vue? So I stumbled in to the README, okay, cool. We go to the web page, found out pretty quickly that their main focus was the Vue layer. It's the core functionality, just produce Vue. No routing, no store, no nothing, just Vue, the core functionality. I like it. I like that thing has one purpose. So I started reading the README, and this is mostly how I see the README. I tend to get bored. So I see the keywords, and I just saw an example. Okay, I just got to copy-paste it and see if it works. Even if it said, do not do this in the caption on both, I would still just copy-paste it and try it out. And this is the way how I learned about that there are two ways to do component creation. I will focus on one of them, but the cool thing is the one called they call single file component, which is you can add with their own file type .vue. But and this is it. This is the single file component. I just got to say that Vue also has the same way as React with JSX. You can do it with plain JavaScript functions, same as you can skip to using JSX in React. But I like using JSX in React, and I also like using the single file component. And I fell in love with this one. You can see it's three parts there. It's a template part, a script part, and a style part. And the template part is it's a mustache handlebar syntax. You can choose what you want to use there, but in my case, I use that. And the script part is just, in this case, ES5 JavaScript. And the style part is just plain CSS. But to use this, you need to have a pre-processing, or you have to compile it with Webpack, Grunt, Gulp, whatever you want to use. And here you can plug and play. You can plug and play if you want to use SAS or less in the style, or if you wanted to use ES6, ES7, maybe ES8 in that case. And in template, you can use whatever kind of handlebar floats your boat. So this is mostly how the components are look in Vue if you go for the single file component way. And the cool thing here, especially with the style part there, you can see scoped, which will make all the styling for this component scoped to that component. And they do that by adding in the pre-processing part, adding the ID of the component. Like in React and other frameworks, each component templates or divs or paragraphs get an ID linked to that component, and that get linked into the CSS. So anyway, now we got our first super easy component. So let's just plug it into the DOM, because the .vue file doesn't do anything. You can't just import a .vue file into the browser and it will run. So this is how much code you need to get it in. It looks pretty similar to React DOM.render. You just need an element, and you need to pass the Vue component into the render function. You can do it with functions. If you skip the .vue file, you just send in the function there with the same. Anyway, I know this is kind of boring, but I just gotta plug through a little bit of README stuff just so you get the basics. And we know, like, it's a JS conference, so we're mostly intrigued about the script part of the single file component. So that takes me over to the Vue data model. And in the Vue data model, we have these 5 names. And it's the first time when I took a look at this, I was, okay, let's try to deduce what they mean without reading any documentation or going through them. Like data, some kind of data, I think, probably. Props, okay, I've worked with React, so I'm biased. I think it's on properties, probably from a parent component or something. Computed, yeah, probably computed values or some sort. Methods, okay, I think it's the same as functions. People have a different opinion, but I think it's something I do with functions or something. And watch, I was thinking, okay, I can add watchers or something to maybe DOM elements or something. So the name's quite easy. So I started on data. Okay, data, it's data. It's equal to get initial state for React. It's the initial state with basic data values, so like strings or ints or data values that are clear on the component it's created. And it gives us easy data binding into our template. As we see here, we can bind the greeting into the paragraph here with the syntax. So pretty straightforward. It's the state of the component. So props. Okay, since I'm biased, I kind of knew what it was before I started. But it's the properties. It's properties you get from the parent component. And in Vue, you have to declare which properties comes into the component. So here we declare an ID over here. And we can use it in the same way in our template or in our script part. We'll get to that in the same way as a regular state or data. And I know I think it was with React E6 or E7, the prop types. In React now, you want to actually define your prop types. We didn't have always do that. But in Vue, they added that you have to declare them, unless the component won't know about the ID if you don't declare it. So we're going to compute it. Okay, so we might think it's some kind of computer values, and that's correct. It's pretty much the same as the data object. The difference is that the data is the initial state, but computed is the mutating state. So computed are just an object of functions. So when we try to acquire the computer value year, it will run the function, and unless it happens if a parameter change or there's no parameter here, or any data value inside. If we're looking at the component value, if we would look at the greeting, it will rerun. So it's caching the function here. So it will re-render when the results are ready here, and not rerun it unless it sees a difference. So for our case, we listen to store values in our applications. So when we got new stuff into our store, it will re-render, and that will get to it. Okay, and then methods. Maybe that's not correct to say that's exactly the same as functions, but anyway, it's class functions in React. It's the functions you want to build your component on. So if you want to use the event system, we can add all our functions in the methods part, and we can you see we can do it with the click handler here, and it will run. And this is how we also get in touch with values from the state, like this greeting, this of the year. So anyway, we're almost done with the boring, or the cool data model. So we're down to watch, and it's a little unclear. The first time I read about it on the README, it said this is not you shouldn't be using this. Okay, I shouldn't be using this. Okay, so why do we have it? So it's like a fallback they have added if you can't solve your problem with computer values or in the functions or methods object. So you can hook watchers. You can add watchers here to watch on data value changes inside a component. Like if the greeting, if a web Rebel greeting is changing, and we want to do an async call to a backend, or we want to do some expensive stuff, we can have a watcher to fire off when that happens, and the component will just keep on showing like it was before. So, but they say it's not recommended. Maybe it will not be there in the future, but for now you have to actually have watchers for some rare edge cases. So let's just see here what's the difference or the similarities of React and Angular, which is I would say the most biggest in the market nowadays. We've seen a lot of similarities to React. The data model is pretty much the same with the state and props. It's Angular, we haven't seen that much, but you saw a little bit of the template data binding. I'm not going to go into it because it's the same as Angular directives or Vue directives. If you want to do an if or a for loop, inside a template. It's very much similar to how we did it in Angular. And that's a long list of directives. So anyway, that's the most similar part there. Also, Vue has two-way data binding. And a lot of people might think that that's not scalable, and that's not that great. That's why Angular didn't win, Angular 1 didn't win over React, maybe. But hopefully, I'm thinking, I haven't actually checked the source code, but I'm hoping that they have fixed a better way to do the two-way data binding, that they actually are managing to remove heavy two-way data binding in the DOM and the JS when components is destroyed or up and down, stuff like that. But we'll see. I haven't tested Vue in a large-scale application, so if anyone have, that's cool to hear. Anyway, so what it comes down to what I think is the Vue factor. And I'll get to it, but first, also quickly, just take a look at the life cycle of Vue. Vue has the same kind of life cycle as React, a lot more actually. The life cycle is a little bigger, or more. You can jump into different steps, and you see the names here on different sides. And the one thing that strikes me is that the Vue names are simple, just simplicity. It's like mounted before updated, destroyed. And you could say that updated pretty much the same. You can read the same from component did update, but that's what I think is the main key part of Vue, is that they go for simplicity. They're trying to just understand or deduce what things mean without reading the documentation. And the thing I hate the most is when I get stuck on things that doesn't solve or I get stuck on reading the stuff I don't understand and actually not solving the problem I'm trying to do with my application. So this is what I really call the Vue factor. They go for simplicity all the way in naming and everything. And also, this won't name clash. If you want a function called updated, you can add it in the methods part. It will not clash with the lifecycle function. One drawback that a colleague of mine actually pointed out to me is that when you search for Vue updated, you will get probably some dude trying to update his something, and probably not get the lifecycle. And component did update will actually give you a more direct answer online. So, might be a drawback. So anyway, let's just get down to our application. I just got to say, this is an application made for our developers and testers. So I call it a dev UX. This is our project. And we learned quickly that when we want to work with Vue, it's the same as working with React. You got to break up your UI in components. You want to break it down as small as possible. And with a single file component structure, you're kind of forced to it, since you're actually adding the template and the styling inside. So it really learned me to appreciate small components. So anyway, this is the UI. Here we have our whiteboard there. We actually have a terminal view, since we hate having a lot of buttons. We just want to use our terminal in the browser. And we got a log field there, getting logs, and a command center, just to some quick buttons. So the first week, after the first week, it looked like this, pretty much the same as it did now, actually, just a lot of stuff behind we fixed. So, but our Vue application actually did the interaction between the whiteboards and did all the magic. And we didn't. And in real life, it's a lot more async than the application actually did before. So we actually need to take a look at how we could fix this asynchronous, and we'll get to it by. But first, I'm going to show you just quickly how we interacted with the application if it runs. Oh, it runs. So this is actually a drawing contest. This guy didn't win. So quickly, get there. Ooh. So here we do interactions with the whiteboard via our terminal by loading a fully functioning whiteboard. So anyway, we wanted to fake this asynchronous to get it a little more inconsistent. It's weird to say, but we want our whiteboard to talk to each other without us just intercepting all the messages and dictating what they wanted to do. So we turn to service workers. And service workers, quickly, there's a script running in the browsers on their own thread. Will not clog the UI, stuff like that. As we can see in this example, if it doesn't run here. Is that we have one service worker actually we can tell, we have one service worker sitting in the view layer, and a lot of service workers just talking to each other. And we get the logs here from one of the service workers. And it's not that good. Anyway, so they really solved the problem where the async, we wanted the async real time to actually show us what kind of errors we had in our application. So, yeah, that is good. It's good. But the problem is that when we get all these log messages via the service worker, we could just show them and not. You could backtrack the DOM elements or maybe the state of the component. But if something happens, we would love to have a store. Like every app now has a store of some sort to cache data. And we all know Redux and a lot of other types of store. The Flux structure has taken over store management in the web applications nowadays. So we thought about actually trying, let's use Redux here. Let's plug and play Redux. But again, my colleague said to me, come on, let's just, we've done this a lot of times. Let's try something else. So I learned about Vuex, which is made by Vue, pretty much the same structure and the mindset as Redux. But one big difference is that Vuex is mutating the state. It's not immutable. And that's in line with their theory of being lightweight and quick, because we all know immutable is a little bigger and often a little slower, but you got a little more control over your state. So we tried Vuex, and it's really plug and play with Vue. Good compatibility. You just have to make your action creators actions and mutations, not reducers, for yourself in the store, and you just chuck it into the main Vue component, and it will propagate down to all their child components. So you can just acquire it inside the component. You can listen to it in our computed values. We had it there, so that you saw the log messages coming in, that it would re-render this component each time a new log message came into the store. So yeah, you can learn about how this store is on your own. It's quite easy. So anyway, I'm getting to the end. Don't got that much time left. So what's cool about Vue? It's simple. I say it's kindergarten easy. They go for simplicity. It's quick and lightweight. We could probably make our application with React, and it wouldn't need the quickness in our application. But I know a lot of people are trying to get web pages to be faster on mobile and other stuff. So it might be a contender there. It's fun to actually try something else than we all know some of us know the React. They call it the React class API, where you do the render function and you do the JSX, and the way React do. And when I took a quick look over the frameworks that were in the earlier benchmark, they all do the same way. They do the rendering, they do the same way as React, they do a class, and they do the render function. But Vue is is one of the few ones that's actually trying to do something else with the file structure, with the single file component, which I think is quite cool, since it's forced me to keeping my components small and quite functional. So I think that's at least sparked some interest for Vue, but you can read more on the README. That's it. Thank you.
To the couch.
Ooh.
I'm supposed to sit further away so our mics
Okay,
don't
sorry,
mess
it's not
up.
right. It's not right enough.
It's not that I don't like you. We sat next to each other at the speaker dinner, so I got to know all about the cabins that people in Norway
Norwegian
have.
cabins, yeah.
Yeah, it's cool. That was a great talk. Thank you so much for that. So I haven't used Vue. I've heard a lot about it because no matter what, it seems like there's always something that you have to hear about a lot that you don't use. That's like how JavaScript works.
It's all right.
And that thing rotates, but Vue is it right now for me. The question I still have is, I feel like a lot of the frameworks are trying to answer a pain point or a problem. Like if you use Angular 1, you might have frustration with two-way data binding and feel like, oh, it's hard to know where things talk to each other and what causes data to change. I'll use React, and it has one-way data binding. Or like, I built this giant React app. I had to invent my own framework because I have to plug all these pieces together. I wish I had more structure. I'll try out Ember. What would you say like the pain is that Vue is trying to solve? You mentioned the small size and the simplicity. Is it just like, I feel like the frameworks I'm using are too big, too complex, so I'll try something simpler? Is that kind of the pain it's trying to address?
A lot of at least React and Angular might have been complex now, but they're quite easy to understand. But Vue is also, my pain, for personal experience, is actually using a lot of time with all these frameworks and all these new stuff popping up all the time. And the one thing that I think that's what I tried to do is to make this process of actually trying something new so fast and easy. And they also made it quick and lightweight to actually sell it to all developers trying to make apps faster and stuff. But it's the simplicity, actually making my life, or as a developer, much easier, faster. I get feeling productive much faster. And that's my experience. That's my pain point is the coolest thing with Vue.
Yeah, that makes sense. Do you find that it changes the way you write non-Vue code? Are there things that you take from Vue that you apply to the other stuff that you do?
I always tried when I worked with React to keep my components small, but it's really that's the most important thing I got from it is to keep my components as small as possible and to get it readable for other people. Trying to structure my UI in a way so that when the next guy comes, it shouldn't be staring at the code for 2 weeks before understanding what the hell it is.
Yeah.
So yeah, that's what I learned the most. We're also working a lot with getting my project to be a little smaller in size, actually cutting pieces out of my package JSON. With Vue, I got so little, the size is so small that it helped me on the way. So it's also like a secondary point.
Yeah, I think I've heard that about some of the new kind of like micro frameworks, that a phrase I've heard them say is your app code should be most of your code, not your framework code. And it seems like Vue is definitely aiming at that. Is your company going to use Vue on more projects? Do you feel like it's been a success?
Yeah, I think so. I will really recommend using it. Again, I haven't tried it on a big scale application, so I know that two-way data binding have killed a lot of Angular 1 apps, and hopefully we'll not do it the same with Vue, but again, I will try it at a medium size, not that much, or small to medium size application. So
like a to-do list or something?
No, not a to-do list. At least a little more traffic than that, but I haven't tried on a large scale like a Facebook app or like a Twitter or something. I haven't tried at that large a scale.
Sure.
So if someone has, I would really like to know how it fares.
Cool. Well, thank you so much for your talk. It was great.
Thank you.
So I want to talk about the dinner invites one more time. Has everyone seen the email that has the link to sign up for those groups? Did anyone not find it? It's on Twitter from Web Rebels? Okay, so you have to follow Web Rebels first on Twitter, and then you don't have to follow me, you should. And then you'll see the link. Again, sign up, that'll close at lunch, so you've got just a little bit of time to do that. Also, I mentioned that I would read compliments that people tweeted about the speakers, and you haven't done that enough yet. So I'm sweetening the pot. I have drink tickets. I'm not going to use them. If you tweet compliments, and then I read them, I'll give you a drink ticket, come find me, and so I'll bribe you to do nice things. Yeah, we've got one more talk before lunch. Jason Lengsdorf is our next speaker. He is a friendly bear. That's what it says in his speaker bio. He likes nuts and berries, as bears do. He's a developer and a designer. He works at IBM Design. He's here to talk to us about monads. Give him a round of applause.
Okay. Well, I'm super happy that you decided to bribe everybody with drinks for compliments right before I went on. I really appreciate that. So today, I want to talk about functional programming. And before we go too far, for anybody who does not know about functional programming, but has maybe looked into it and been intimidated, this talk is for you. For anybody who is very familiar with functional programming and is ready to judge me for my correctness, get ready to judge. It's going to be awesome. So before we do that, let's talk a little bit about me. Sorry, that's a picture before I shaved. So this is what I look like now. And I've been doing this for a while. I started in about 2003. I got my start on MySpace, as I think most people in my generation did, building custom headers and super sweet little Flash animations. I'm really big on process and efficiency, which is one of the reasons that I got into functional programming, and it's one of the things that I do at IBM. It's, kind of why they brought me in. I'm also very big on work-life balance. That's a whole different talk that I do, but the short version is that once upon a time, I worked so hard that I got stressed out enough that my beard actually fell out of my head. I changed things, and my beard is back. I got better. I'm currently working as a developer at IBM. I've written a few books on nerdy shit, and I'm really, really good at bear hugs. I do a lot of bear jokes, I'm sorry. So before we get too far into this, let's talk a little bit about what I'm not here to do. Because there's a lot going on in this talk, and it can be taken a number of ways. So let's start with what I'm not doing. The first thing is, I am not here to convert you. I don't want to make you into a functional programming believer or a functional programming purist. I'm also not trying to convince you to convert all of your code to be written a certain way. I don't think that that's a healthy way to approach programming. I think that one of the greatest things about JavaScript as a language, and a lot of the more flexible languages, is that we can do anything with them. And if we take advantage of that responsibly, then we can get a lot of really, really good things out of it. So you should use the good parts. I personally believe that the best way to get stuck in life in general, but also especially in tech, is to become very dogmatic about the things we believe. If I'm only willing to do something my way because it's my way, or because it's the way that I was taught and everybody else therefore must be wrong, I'm not going to get very far. And in web, that's a great way to end up becoming a legacy developer, and that's not a fun space to be in. So let's talk about what I am here to do. I am here to try to share some of the things that I've learned through my experience in building web applications to make your life a little bit easier. So I'm hoping that through this talk, you're going to learn a few techniques that are going to improve your code quality in a lot of situations. But again, this is not a silver bullet, so it's not going to fix all of your problems. Cool? Cool. Okay. So what is functional programming? So functional programming is kind of an interesting thing. Who here has tried functional programming or looked into it a little bit? Okay, of all those hands, keep them up if you kept doing it. Okay, so a handful of hands came up. Okay, so you guys are going to be super pissed at me by the end of this talk. So what does this mean? This was one of my very first intros to functional programming, was looking at the documentation. This is from Ramda.js, and I love Ramda. I use it all the time, but I'm going to pick on them really hard for a minute. This makes no sense to me at all. I have no idea what it is. And if you do know what this means, this would be a great time to fake an urgent phone call, because it all goes downhill from here. So then you start digging into the examples, and they don't get a whole lot better. So we're looking here at the lens, which what we were just looking at, this is called the signature of the lens function. Now, I'm going to be totally honest, I still don't know what this means. But it's something about what goes in and what comes out, and those letters, I assume, stand for strings or arrays or something. So it's not super clear. But then you get to the examples. And the examples, rather than showing you how it works, introduce, I think, 6 additional functions that you need to look up before you can understand how Lens works. So it's really, really opaque. And it gets worse because the jargon in functional programming is horrendous. When I first started looking into it, I thought, okay, this looks useful. I could try this. And I asked somebody, hey, what should I do to learn functional programming? And they told me, go study category theory and then come back and start looking at code examples. I was like, I'm not going to do that. So you just start seeing all of this ridiculous jargon, and it just goes and goes and goes for days, and finally, you're like, you know, I get it, I give up. I don't want to do this at all. So, I love this GIF, by the way. I could watch this all day. It gets overwhelming, though. You just kind of start to feel like, okay, this is that stuff for the really advanced, like math majors, PhDs, people who are not me. Because I'm not. I'm a college dropout. I have no education in computer science. Everything I've learned, I mostly learned from W3 schools. So I have like no formal training whatsoever. So when I start looking at, you know, monads or category theory, I go blank, right? But I don't actually think that's what functional programming is, and that's why this space pisses me off so much. Because I feel like functional programming is this incredibly powerful tool that isn't that hard to get into if you can avoid the jargon. So let's try this again with the jargon-free version. And I'm kind of lying about that because I'm going to introduce some jargon, but I'm going to explain it. So functional programming is code that is designed to help make our code easier to understand and debug. It makes it cheaper and easier to maintain. I'll talk a little bit about why. It's more legible once you get your head around the style of functional programming. It's more reusable, more on that. More testable, which is probably my favorite part of it. And it's less error prone. And we can do that by following 3 fairly simple rules. So the first one is, we want to try to use functions instead of loops whenever possible. And I know that sounds a little crazy. It sounded crazy to me when I first started looking at it, but it makes more sense as you look at the structure. You also want to try to always return the same result if you have the same input to the function. And if you're rolling your eyes at me right now, I promise there are reasons. And you want to write functions that do one thing, no more big mega functions. So let's look at each of these steps kind of in depth and look at how. So the first thing, functions in most cases are better than loops. And let's look at an actual example. So if you're looking here, this is a list of beverages, and if you notice, there's a problem because vodka made the list of beverages. And I realize as I'm saying this that I'm in Scandinavia, and like clear alcohol is totally a thing here. So I'm sorry, everybody. But we want to use a program to fix this beverage list. So a little bit of jargon before we get started. There are 2 ways that we could solve this problem. There's imperative programming. And imperative programming is probably what we are most likely to encounter in the real world. And imperative programming is an idea of your program explicitly describes how something is done. I'm going to make some American pop culture references. I hope they translate. So this is a movie called When Harry Met Sally, and the way that she orders food is extremely imperative. It's very, very detailed. I like it heated, but I don't want the ice cream, and I want it on the side, but it's strawberry instead of vanilla. It's very, very, very detailed, and there are a lot of places for it to break. And it's also extremely easy to get this wrong, and it's hard for the people reading it to follow. So another way to approach this is what's called declarative programming. And this is one of the concepts that kind of sits underneath functional programming, which is the idea of describing the result rather than the steps to achieve that result. This would be a way of ordering declaratively. Doesn't matter, doesn't care if they're sunny side up or scrambled, doesn't care if they're hard-boiled, he just wants them all. So does that make sense? Everybody with me? So let's take a look at some code and actually fix that beverage list. So the first way we're going to do it is we're going to look at doing it imperatively. And so you can see here, what we're doing is we're setting up a for loop, then we're setting up an if, and inside of that if, we're setting up another for loop, and then inside of that, we're setting up another if. And ultimately, what we're trying to do is decide, for each person, if the person has beverages, loop through the beverages, see if that beverage is vodka, and if it's vodka, fix it. That's a lot, and it's something that we lovingly refer to as the pyramid of doom. The pyramid of doom is that idea of just infinitely nesting everything. And you can imagine in more complicated data objects, this pyramid gets deep, and it gets really, really hard to debug. Because what happens if that structure changes somewhere between the first and seventh loop, right? Do you have to rewrite everything in the middle? Maybe, probably. So this is not a particularly maintainable way of approaching this problem. So let's take a look at a declarative solution. So declarative code is going to, instead of setting up loops, we're going to write a function called fixBeverage. FixBeverage accepts a string and replaces the word vodka with whiskey. Okay? Then we're going to write a function called helpIfConfused. And what that does is it takes a person, and it returns the person, but it replaces the beverages with a fixed beverage, if that exists, right? And then finally, we map the helpIfConfused to all the people. So instead of setting up multiple loops, we set up a two steps, same as the imperative solution. It's 2 steps. Get all of our people, check for beverages, get all the beverages, and fix it, right? We're doing the same thing. At the bottom, we take all of our people, and we map a function to it, and then inside of that, inside of each person, we map a function to the beverages. Same solution, significantly easier to maintain. Because if something changes and that beverages item ends up being nested 2 or 3 levels deeper, we don't have to rewrite a pyramid of doom to make that change. We just have to rewrite that beverage function, and we've solved the problem. So the result that comes out is identical. We get the list back, and vodka is fixed. So for anybody who's not familiar with it, I use something called mapping. Mapping is an extremely powerful way to apply a function to every element in an array, or a list, or however you want to, an iterable. What that means is something like this, where we have a function called double, which will take any number, multiply it by 2, a list of numbers, and we want to double each one of those. What we would have to do imperatively is, or I don't even know if you'd call this, without using map, is you would set up an empty array, you would loop through each of the numbers, and you would run the multiplication to get your doubled list. If you do that using map, you don't actually have to do that. You write the function, you get your list of numbers, and you just map that function. It's much cleaner. It's a little, and once you get your head around the terminology, what mapping is, it's a lot easier to understand than a bunch of loops and fors and things like that. So something that I would really recommend for everybody, try to get familiar and comfortable with the different array methods. And I'm going to list several of them at random. There are a lot more than this. Filter is very good for getting, if you've got a list of numbers, you can apply a condition, and if that condition is true, it keeps it in the list. Super useful. Sorting, if you want to get them in alphabetical order, or if you want to apply a sorting function, you can do however you want to do that. Every means that if everything in the list is true, then it matches. If everything in the list matches, then it comes back true, or all sorts of good stuff. And there are many more of these. So, everybody with me so far? All right, I see some nodding heads. Rule number 2: we want to always get the same input given the same, or the same output given the same input. And if you're looking at that thinking, well, of course, that's what code does. If you execute code, it's always the same. And that should be the goal, right? If we start our program, it should be predictable. But there are a lot of edge cases where that's not true. So let's do a little bit more jargon. Let's talk about pure functions versus impure functions. Who has heard that term before? I see a lot of hands. Awesome. Okay, so let's look at another scenario. We're going to tell people about our favorite thing. And I bet you can guess, my favorite thing is whiskey. So we have a function, and this would be an impure function. We set a global variable called whiskey. Then we build a function called describe my favorite thing, which grabs that global variable and returns a sentence describing my favorite thing. Okay, so far, so good. Then we get a feature request. Okay, great. So let's clarify. I don't like any whiskey. I like aged whiskey. Okay, so good, that's a good thing, I want that. However, this then starts going through QA, legal gets involved, and we decide, okay, whiskey's not a good thing, this is a family-friendly app. So they change what my favorite thing is, and they change it globally to scented bubble bath, okay? And the problem is, if we've got a sufficiently complex app, we might end up with code that looks like this, where we set whiskey up at the top, functions are happening, and down at the bottom, it says that I like to drink bubble bath. That is not what I intended when I wrote this program. And it's really difficult to debug this, because, again, you don't know where these things are being handled. These functions are black boxes. Black box functions are almost always a bad idea. So instead, let's look at how we can make these functions pure, get the same thing. So if we take this, and instead of making it a global variable, let's just accept that variable as the argument. So really nothing changed, except you have to explicitly pass what you're sending to that beverage, or to that function, as an argument. So when you put in whiskey as the beverage, it'll say, I prefer to drink quality whiskey. If I put in orange juice, it will say the same thing, only orange juice instead of whiskey. Very predictable. If we want to clarify, we have to pass in the thing that we're clarifying. And when we make it family-friendly, that's always going to return scented bubble baths. Notice that it's returning and not setting a global variable. And that makes it significantly easier to debug. So if we are describing, and I left off, no, I didn't. So we have, our favorite thing is declared as whiskey, and we can do it as a const because we're not going to modify it. We then clarify it using clarify favorite thing, and we also get a new favorite using make family friendly. And when we call these functions, we can see what was passed into each one of these. So we're calling it with my favorite thing, so we can look up in the code to the declaration and see immediately, okay, that makes sense, that's what we wanted. And then when it gets weird, describe my favorite thing, we know that we should probably look at what new favorite is because something's not right. Okay, so our debugging just got significantly easier. And another bonus of doing it this way, when you have functions that always return the same output for the same input, you get something that's called referential transparency. And this is a big word that basically means same in, same out. And what makes this so powerful is that we can replace the function call anywhere in our code with the result of that function call. And for testing, this is huge. Because it means we don't have to test our entire app. If you're testing a series of functional calls, you can test each one as a unit test and know that if that unit test pass, anything that calls that function before it runs itself is also going to pass because there's no way that it couldn't if that function is pure. So that means that we're looking at something where if I say, I love clarify favorite thing cheddar, I love aged cheddar, those two declarations are the same because of the referential transparency of clarify favorite thing. Clarify favorite thing with cheddar as an argument will always result in aged cheddar the way that we wrote that function. And this is really, really, really good for testing because we can literally test that. And we know that that's true, and if it's not true, it means that somebody broke our function, or we broke our function, more likely. Added bonus. This allows us to do something called composition. Composition is the idea of plugging together multiple functions to make super functions. And a really useful, we'll look at some more useful cases of composition here in a second, but what we can do is take this describe my favorite thing function and the clarify favorite thing function, and we can compose them together. So a little bit of weirdness with compose. It might look like it's going to run from top to bottom. It actually runs from bottom to top, because if you were to put those on a single line, the function on the right gets called, and that result gets passed to the function to the left of it, to the left of it, to the left of it, until you get a result. There's a way in Ramda, if you want, you can use pipe, which will reverse that order if it's more logical for you to go top down. For me, with the functions, it made more sense to think about it as like each one calling the next. But what this does is when you compose, we pass in the functions as arguments. Notice that we're not calling them. And what that gives us is a super function that when we pass in whiskey, it will clarify whiskey, so it changes it from whiskey to aged whiskey, and then it passes that result, aged whiskey, to describe my favorite thing. So our result is, I prefer to drink quality aged whiskey. This is extremely powerful because each of those functions is individually unit testable. And when we start reusing these later in our code, it'll make our code base a lot smaller because maybe just clarify favorite thing could instead be clarify whiskey, and we have another one that would be, I don't know, clarify juice, and we would change out instead of aged, it would be fresh squeezed, right? So any of those things could be done, but we wouldn't have to rewrite the I prefer to drink quality blank. That function continues to be useful. So composition, like I said, is the same as calling it like this. Describe my favorite thing with clarify favorite thing as the argument and whiskey being passed to it. It's just a little bit easier to read. The benefit being you don't have to drop the data in up front. So rather than having to build a gross loop that would call each result, you can build this function once and then map it to an entire list to get all of your results. Okay? So let's do, each function does one thing. We have a scenario here where we have a list of, we've got 4 albums. I was too lazy to make it small enough to read. So just trust me that there's 4. And what we want to do is filter by genre. So there's hip hop, rock, and indie on this list. And we want to filter down by genre and then sort by the artist. Now, if you can notice that when you're sorting, this isn't like a typical sort where you would just be able to do A to Z, because we have to get into the artist field and then sort by that. This is another really good use of the array methods. So if we do this as an all-in-one solution, like a monolith function, so to speak, you would end up getting the albums. You build an empty array to hold the filtered albums. You have to loop through them, run an if statement. If it matches, then you would do the filtered. Push, then you would have to also do the sort, and that takes another function, which is going to then give you the ordered albums. And the way that sort works is a little confusing. I have to look it up every time I use it. You basically compare the two things and provide 1 or -1 as to whether or not they should go up or down, or 0 if they're the same. Just look it up. Like, you're never going to memorize it. But if you do it as one function per step, this gets a little simpler. If you create a function called byArtistAscending, you just have to define your filtering function, okay? And then I have another function called getOnlyIndie that checks for the indie genre, and then I can run them just chained. Basically, we could do this with Ramdas functions that would allow us to compose them, but since the array prototype lets us just chain them together, we don't need to bring in a library for that. So now we've got, we start by taking our albums, we filter to just the indie, and then once we've got our list of indie, we sort it by artist ascending. But this gets more powerful, because we can actually make this even more useful. What if we wanted to allow our users to sort by genre kind of arbitrarily? Well, we can take our initial filtering function and run something called curry, that I'll talk about in just a second, and then we can build our different filtering functions just by calling filter by genre with the genre that we want. And then hip hop is albums, filter only hip hop, right? Super useful. But what's that curry thing? And it's not this curry, it's this curry. Currying is named after Haskell Curry, who was one of the mathematicians who helped popularize the concept. And what it means is that you can call the functions in stages. So imagine that instead of having to give all 6 arguments, you could call that function 6 times, each time adding another argument to the front of the list. So let's look at an example of how that works. If we wanted to add 2 numbers together, we've got add numbers 1 and 2, and it will return numbers 1 and 2. If you tried to call it without currying it with add numbers and the number 2, it would fail. It would give you an error. But if you curry it, then we can call it with add number 2, and it'll give us another function. And that function then accepts the second argument, but it's already got another number, it's got the number 4 in it. So we're able to take a really generic function and make a more specific function out of it using currying. This is extremely useful. I mean, this is a pretty trivial example, but as you start looking into, like, let's say that I've got a list of tags that I want to filter against, and so I need to send in a user object and a tags object, I could curry a function with the tags object already in it. So then I just have to pass in the user object, so it makes it easier to map against an array of users. Does that make sense? I see a couple people. Anybody still awake? Okay. So let's take a minute. Let's recap. I think we got sufficiently nerdy. So functional programming is something that is going to allow us to write code, and this is just a straight copy-paste, so I'll go fast. It's easier to understand and debug. It's cheaper and easier to maintain. It's more legible. It's more reusable, more testable, less error-prone. And all we have to do to get all of those benefits, remember that functions are typically going to be better than loops. Always return the same result given the same arguments, no global variables, no side effect. I'm not going to talk about side effects. Basically, accept an argument, only use things that were passed as an argument, always return a predictable result given those arguments. And make your functions small. Write functions that do a single thing. Now, this is just the very, very tip of the iceberg with functional programming. And if you go deeper, you're going to start to see things like monads, like category theory, and that stuff can be super useful, but you don't need it. You don't need to be a PhD to start using functional programming today. You can get all the benefits without learning a single mathematical term. So I hope that, that you guys will do that. That's what I just said. And that's all I got. So thank you very much.
Welcome to the couch.
I almost tipped it over.
Yeah, it's surprisingly flimsy.
It's not built for American size.
So I got a lot of compliments on your beard.
Yes.
A lot of compliments on your slide. They was like equally, the slides are great. His beard is magnificent.
I worked really hard on my beard.
The slides are fine. Those were easy. The beard, though. Someone also asked, but what is a monad?
Oh, God. A monad is a way of, I'm going to get this wrong, Bodil's going to kick my ass. A monad is a mathematical way of ensuring that you don't get errors. It's like a container for data. So it's super complex. It's basically like putting your data in a bubble, and then you have to do something to like get data from one monad into another monad that I forget the name of. It's very complex and not particularly useful unless you're writing something for NASA. How about this? Monads are something you don't need to care about. That's
So I was reading the speaker bios and the talks and stuff, and then last night I woke up in my like jet lag, groggy haze, and I wrote stuff down in my notebook, and I pulled it out this morning, and I saw, oh, you like monads? Name 3 of their albums. And I don't know what that means, but at 3 a.m., that was really deep and profound to me. Another question I had watching your talk was, so web developers, I think all developers do this thing, where we see the new shiny thing, we're like, this is amazing, and then it's like if you have this bottle of like barbecue sauce, and you take a little bit, and you're like, this is great, and then you just dump it on everything, like, we need this everywhere. And sometimes that backfires a little bit. Like, there's this pendulum of we use this thing, oh, now this thing sucks, we never use it again. And I don't know, we waffle back and forth. But I feel like in that waffling, sometimes you learn where stuff actually fits well. Have you seen areas where functional programming maybe isn't the right approach, or it struggles to provide value? Does that make sense?
Oh, yeah. I mean, functional programming is really good when you're dealing with data. Where it's really bad is when you're dealing with the DOM, because by nature, the DOM is impure. So whenever you modify a DOM element, you are doing an impure function. So what that means is that, I recommend a hybrid approach. So if like really purist functional programming will say, well, what you should do is you should create an impure object so that all of your impure functions are flagged as impure. And you can do that for organization. But really what I found is use functional programming until it's more work to work around whatever it is you're trying to make functional than to just fucking write clean code. So if it's, when you're dealing with the DOM, when you're removing or adding elements, just remove or add elements. Do it cleanly, make sure that that function only does that, and you're going to have a much better time than trying to figure out how to make the DOM into a functional set of functions.
I think you use monads for that.
Right. Yeah.
Yeah, one of the things I liked about your talk was how approachable it was, where you can like ease your way into functional programming and take these things that are very easy to get started with and deliver a lot of value. So say someone watches this talk, they look at the slides, they start to use all this stuff, and they really like it. Is there like a next step? Is there the next thing that you look at after you have all the array stuff and kind of the...
So, I mean, the way that it worked for me was as I saw what like composition and mapping and you get into all the array functions, and I was like, man, this is pretty cool. So I started looking at Ramda, and I saw what a couple things that Ramda could do. Ramda.js is, I have links. My slides are online if anybody wants to look, and the last slide is a list of like helpful things to get you started, some articles and also some libraries that you can use. But I started looking at what was available in Ramda, and that led me to ask questions. They've got a Gitter chat. If you haven't used Gitter, it's kind of like crappy Slack, but for developers. And if anybody's here from Gitter, I'm so sorry. No, it's a great tool. It's designed specifically to like take a GitHub repo and turn it into a chat room so that you can discuss something. And Ramda has a very active Gitter channel where if you've got a question, somebody's going to help you. And the first person who helps you is going to just spit out the most complex like composition of Ramda functions you've ever seen, and the second person will explain what that meant. So just be patient and sit tight, don't panic. Help is on the way.
You showed some of the Ramda docs where they have the type signature, and then types didn't come up in your talk, but they sometimes get mixed in with functional programming. Do you feel like that's stuff you need to learn, like type systems and type signatures in general, or is it learn if you want? I don't know.
So,
how do you feel about that?
I mean, I feel like one of the hardest parts about being a JavaScript developer is that everything is useful. Strongly typed code is awesome, but for somebody who's just getting started in JavaScript, I don't want you to not write JavaScript while you learn strongly typed code for 9 months. I want you to start writing programs, see how this stuff feels and works. And so I don't push strongly typed code until there's an actual need for it. If we need to, at IBM, if we're trying to write something that always needs to work all the time, then yeah, I want static analysis on it. And to do that, I need strongly typed code. So if there's a need, sure, use it. If there's not a need, play with it, see how it works, but don't prevent yourself from building something because you feel like you don't know all the right stuff. I feel like that's the hardest part, especially with the, there was a joke about JavaScript fatigue. I think that JavaScript fatigue it's more like JavaScript paralysis because people start an app and they go, oh wait, I need to use React plus Redux. Oh wait, also need to use sagas. Wait, I need to use Thunk. What the fuck is a Thunk? Let me do research for 4 days. And then they've never written any code and they still don't quite know how it works because they never used any of it.
But you read a lot of Wikipedia articles in those 4 days.
You're right. That's true.
Yeah, awesome. Well, thank you so much for your talk. I really enjoyed it. It was a great intro to functional programming. Good job. All right, we're off to lunch. We'll be back at 1:30. Reminder, the cards that came with your badges will get you lunch at the food court. So see you then.
till I find you. And I know you're out there somewhere.
Welcome back from lunch, everyone. How was it? Was it good? Hooray, applauding for lunch. I like lunch too, I can appreciate that. Thank you all for coming back. Our first talk is by Tiberius Heflin, who has maybe the coolest name, no offense to the other speakers. I don't know, it's close, it's a very cool name. She is a security engineer at Portland General Electric, and she is here.
No, I've moved, but that's fine, I'll cover it.
I don't know what she is. She's great. Please give her a round of applause.
Hiya. Good afternoon. I hope everybody enjoyed their lunch. We're going to take some time away from JavaScript to talk about the art of social engineering. So I'm Tibbs. This is how I imagine myself when I'm on stage to avoid the jitters. And I grew up in Scotland, so you might hear a little bit of my accent come through. I currently actually work at Intel, and I do security assessments on free and open source software while working at one of their sites in Oregon. At 24, I left a career in HR to study computer security, forensics, and ethical hacking. And potentially, because I did work in HR, social engineering is a point of absolute fascination for me. So now that the introduction is out of the way, I'd like to ask you, what do you think that a hacker looks like? Depending on your age demographic, you might think of Elliot, you maybe think of Neo, or if you're like me, your mind goes, that's right, to the '95 classic Hackers, starring Angelina Jolie and Johnny Lee Miller. It was a roller coaster adventure following a group of teams with awesome names like Crash Override, Acid Burn, and Serial Killer. This is definitely the world that I thought that I was entering when I got into security. I don't want to brag, but teenage me was really good on the rollerblades. Sadly, I and most of the hacking world will never be that cool. The reality is that the real giants of security, and especially social engineering, are a little different. This is Kevin Mitnick, who was arrested the same year that Hackers came out. He's arguably the most famous hacker and a master of social engineering. This is Frank Abagnale Jr. He was pulling off amazing social engineering stunts back when it was just called being a con man. And Hollywood even made a movie about him. More on that later. This last example is lesser known. Her name is Carrie Farrell, and she was dubbed the hipster grifter. Now, she started out with small scams in Salt Lake City and eventually made her way to New York City. Once there, she lied her way into a job at Vice magazine before convincing her friends and a sizable part of the late 2000s internet that she was very ill and in desperate need of money. She was soon caught out on that lie, however, and ended up in prison. Actually, all of the people that I've just talked about ended up in prison for their activities. These people tricked others out of their money, out of information, and out of goods. So why would anybody look up to them? Why am I talking about them right now? Well, just like we appreciate those who find bugs in code and ways to exploit systems, we in security admire social engineers because they find bugs in the way in which society interacts and expose them. While the original intent for some of these activities was for the lulz, social engineers now work to show the fixes that are needed to be patched in our everyday interactions and social contracts. So you know this is a serious part of the talk because we've moved from pictures and GIFs to text. It's easy to have a vague idea of what social engineering is. Some people say it has to include malicious intent. Some people say that it even includes the act of befriending somebody. Others, like the question of ninjas versus pirates, there are lots of opinions here. So for the purposes of this talk, let's go ahead and define social engineering. The tactics often employed in social engineering exploit cognitive biases in human behavior, especially the values that were taught as children: kindness, helpfulness, and trust. If humans were systems, these values could be seen as both bugs and features. There's a lot to be gained from a social engineering endeavor: information, access to sites, money, anything really. It's only limited by the actor's imagination. Often social engineering relies on direct or implied non-truths, with the goal being to get the target to act in a way that they normally wouldn't. And there are lots of ways to lie. Lies are surprisingly easy. Just ask any kid that's been caught doing what they shouldn't. I'm sure they'll produce a great one for you. I'm 6 feet tall, or, since we're in Europe, I'm 163 centimeters tall. Lies are easy, but they're not always believable. The believability of a lie is in its framing. And in security, it's this framing that shows common traits. And we can use these to categorize attacks and find ways to combat them. In the rest of this talk, we're going to be looking at some common and not so common tactics to look at ways in which they can be combated. Now, I looked, but I struggled to find any Norwegian examples of social engineering. So most of the examples I will be using will come from the US and the UK. I would love to hear about local examples, though, if you know of any. So please feel free to tweet me about them. So our first example here, or tactic here, tailgating, is probably the second best known social engineering tactic, at least in the US and the UK. Tailgating is when a bad actor follows somebody into a secured area without their knowledge. And piggybacking is when a bad actor tricks somebody into allowing them into a secured area. So I don't know that I'll be able to see them. Can I get a show of hands? How many people have work IDs that you have to have in order to access your office or building? Yeah, quite a few of you. Companies are normally really good at enforcing these types of rules, and this is because having an unauthorized person in the building carries huge risks. These include theft of equipment, theft of proprietary hardware, theft of intellectual property, and even potentially workplace violence. It's also a high-risk activity for hackers. If they're physically there and they get caught, it's almost certain that charges are going to follow that. It's a lot harder to escape physically than it is to hide your tracks on the internet. So I worked with a company in Oregon who got hit. They had a person come in claiming to be a workman. There was some trade work being done in the building, and so it didn't seem unexpected, but this person said that he had lost his pass and needed a new temporary pass. And you know, the security guard, he just wanted to be really helpful, and they got to chatting, and the guy got a new pass. And it wasn't until 3 days later that they realized this man wasn't actually a workman, and he had had access to the building for 3 days. In those 3 days, he stole several thousands of dollars of worth of hardware, including laptops that had proprietary information on them. And that's not something that can be got back, even if the hardware is brought back by the police. So it's really important to follow through and ensure that unauthorized people don't access your physical site. These attacks work, though, because we're taught to be friendly and helpful people. I mean, I do it all the time. I want to help people around me. It's a kind of a natural thing. These attacks are also more common around holidays, especially Christmas. I mean, who doesn't want to help the overburdened delivery man who might have a package that you're waiting on? For the hacker, getting an employee to help them is great. It buys them legitimacy. If you see a stranger in the office, but they're with your coworker, you're a lot more likely to not worry about it and assume that your coworker has done the due diligence to ensure that these people are who they say they are and should have access to the building. So our next tactic is phishing. Phishing at this point is probably the most common type of attack. Phishing is seeking sensitive information through a deceptive email that masquerades as a trustworthy source. Has anyone here not received a phishing or spam email? Yeah. Most often, phishing is a wide net activity, which means that they just send an email out to any email address they can find, because even a 0.01% response is still productive for them. As this graph shows, the number of phishing emails is increasing at an incredible rate. And I think the most common example of this, or at least the one that has kind of worked its way into our minds as a society, are the emails that you get from the Nigerian prince. These types of scams are also called advanced fee fraud scams or 419 scams. And the 419 scam name actually comes from the section of Nigerian law that governs fraud and con artistry. So if you've not actually heard of this, what happens is that you receive an email from somebody claiming that they have a large amount of money that they need to move from point A to point B, normally out of one country and into another, but that they need somebody in your country to help them move that money. And they say that they will give you a portion of the money in return for your help. And if you reply to these, it can be really interesting because as you go through it, they say everything's fine, and then suddenly there's a problem. Perhaps there's a fee that needs to be paid, and they don't have the money. They need you to provide that money. So let's say you provide that money. Everything sounds fine and dandy until, somebody needs to be bribed, and maybe you give them a little bit more money because, at the end of the day, you're going to get a lot more money than you're putting out at the end of this. And every time you give them a little bit more money, something new happens that they need a little bit more money. And this continues until either the person who's giving money gets wise to it, or they run out of money, and then when they contact their person that they're trying to help, either wanting information and demanding to know what's going on, or saying that they have no money, that person disappears and moves on to their next target. So 419 scams have actually been around for a really long time. They were traced back to the Spanish prisoner scam from the 18th century. And this type of scam was really common in the 20s. So it's gone from letters to faxes to emails, and we're even starting to see it in SMS texts. And it's so common that in the 20s, the American Secret Service created an address for victims to send information to let them know that they've been targeted, to try and seek help. And it may seem strange to a lot of us who really only know of the role of the Secret Service that they play in protecting the American president. However, their original mandate was, which they still carry out, was to investigate counterfeiting of US currency, among other frauds. So in March 2016, a company in the US called Pivotal, just on a normal day, in that time of year, it's tax season in America, and a payroll employee got an email from the CEO asking for the information, the tax information for everybody in the company. And the email looked legit. He didn't think anything of it, so he pulled all the information together and sent it off to the CEO, except that it wasn't the CEO that asked for the information. It was an unknown actor. And this information is now out in the wild, and these people are all at risk of identity fraud for the rest of their lives because of it. Unfortunately, Pivotal aren't the only company who have been attacked in this way. A company called Monarch Beverages, who are based in Indianapolis, were also hit by the same type of attack, not once, but 2 years in a row. It can be really difficult to distinguish some of these emails. There's lots of types of phishing. The Nigerian prince emails, like I said, are like a simple wide net activity. The pivotal and monarch attacks are good examples of what we call spear phishing, and that's a highly customized and targeted attack on a target that has access to a large amount of information. We also have identified whaling or CEO fraud, which is a phishing attack that's aimed at high net worth people who can be subject to blackmail or other activities once they've given out information. There's also what is unfortunately called smishing. This is SMS phishing, where links are placed in texts asking people to take immediate action. So I know I've received one claiming to be from PayPal saying that my account's been locked and I need to click on this link in a text and give them all my information. And as that kind of comes more into play, social media phishing is becoming a far larger thing. People on Facebook are receiving emails from long-lost friends. These can be really insidious because the person might contact you and say, oh, I remember you from high school or middle school, and I don't know about you, but I've got a kind of fuzzy recollection of that time period. And so I might start talking to this person, and that's just like a normal conversation. We start talking about the weather and about old times, and then maybe the pet that I had in high school, what was that cat's name again? And, oh, didn't your mother, didn't she get married? What was her maiden name? They try and pull these little facts out of you that they can use to then go and change your email account password and log into it and get a lot of really good information that they can use for identity theft. It's estimated that 600,000 Facebook accounts are compromised because of this tactic every day. So it sounds like it would be easy to pick out, but it can be quite difficult. A follow-on threat from phishing is ransomware, and these are often presented as an attachment or a link that they send you to, and there's an automatic download at the site, which downloads this program, which actually encrypts information on your hard drive, and then gives you a lovely pop-up like this that asks for your money in order to get your valuable information back. In April last year, a news company in the US estimated that $209 million had been lost to ransomware attacks in the first 3 months of the year alone. And that was just in the US. The worldwide numbers are far larger. Now, it's not actually just finance that is at risk with ransomware. It seems like something out of a game, but in March last year, an unidentified healthcare provider reported a critical monitoring machine going down in the middle of a medical procedure. And this was due to a virus scan that had been triggered by a ransomware attack on the network. In this case, nobody was hurt, but in the next incident, the story could be very different. And currently, healthcare facilities and education facilities are prime targets for these attacks because they have so much vital information. So let's look at an example email. Let's just take a couple of seconds here. How many indicators can you count that this is a non-valid email from Apple? Well, all of these highlighted spots are signs that this is not a real email. Firstly, I'm not sure that Apple actually used this servidor.gugesh.eu address. Also, the Apple logo is incorrect. I don't think I've ever seen them actually put a TM mark next to that, and I'm pretty sure that it just normally has the Apple. I don't actually use Apple, so some of this is a little strange to me. Also, if you were an Apple customer, I'm sure that they would address you by name because you're their customer and they know who you are. And the next one is they're telling you something horrible has happened and that you need to take immediate action. This is always a sign that something may not be quite right, especially when they give you a link within the email. Hovering over this link, it actually goes to metcornbread.com. I'm pretty sure that's not an official Apple email account, or not email account, website. And as you look through it, you'll probably notice there's a couple of spelling and grammar errors. These are actually done on purpose to try and weed out people who are less gullible. So the way to combat this is to verify your source. If you get an email from somebody and they're asking for immediate action, contact them via another method. So go to the website, navigate to the website yourself and log in a normal manner and check your account, or even call them to see if they know what's going on, if it's the type of company that you can contact that way. Don't use links in the email. They're always a bit suspect. And be critical of your sender email addresses. That first one that we looked at doesn't look right. And distrust demands for immediate action. Take a moment. I know it can be difficult, especially if it's an account that's really important, but take a moment to think before you act. And also think about the information that you're putting online. A lot of these attacks will actually, if they're really interested in you, they will look at your Facebook and they will look at your Twitter and any social media accounts that you have to try and glean information about you that they can use to make their attack look more legitimate. So we'll move on to pretexting, or in Scotland, blagging. This is an invented scenario that is specific to a target. There's normally a lot of previous research and setup. And this information is often used for legitimacy and to make the con seem more real to the target. So some examples here. Mitnick, who we talked about earlier in the talk, tells this amazing story about how he suspected another hacker of working for the FBI. But at the time, all he knew was the guy's phone number and a name, which he was pretty sure was fake. So at the time, in the 80s, the way that phones were set up in the US, you could tell who had issued a phone number, what telephony company had issued a phone number, and then contact them about that number. So that's what he did. He called them and just spoke to a normal customer service agent. And when she asked his name, he said, actually, it should be under the U.S. government. It's not under my name. It's under the U.S. government. Hoping that she would be helpful enough to actually tell him the name on the account. She did. She said, "Are you Mike Martinez?" And he's like, "Yeah, that's me. I'm Mike. By the way, what's my account number?" And through just being very friendly and giving the right answers, the right questions, he was able to get a lot of information out of the agent. She was really helpful and even ended up giving him the account information as well as the last 3 months of call history in order for him to look at. So for me, pretexting is probably the most interesting form of social engineering because it's the most creative and it holds the most potential. You can get a lot of information. The Hollywood movie Catch Me If You Can was actually based on the life and exploits of Frank Abagnale. And he's amazing. He's done some really incredible stuff. In his late teens, he actually pulled an amazing scam off with the Pan Am airline. He found out what hotel their pilots and stewardesses went to, and he contacted the head office and said, "Hi, I'm a new pilot, and the hotel has lost my dry cleaning, and I have no uniform, and I need to get on a flight, and I can't do my job without it." And the woman on the other end gave him the name of the local company that made the Pan Am uniforms. And through the information that she gave him, he was able to go there and get a new uniform and then walk onto a flight. And he flew to, I think, over 29 countries on 200 and some odd flights during the period that he was able to convince Pan Am that he worked for them. It's unbelievable. The movie is great. I highly recommend watching it. And we're now seeing pretexting scams on a large scale. In America, these are often targeted at the ill-informed or the elderly. The best example, I think, or the most common example in America is that people will often get telephone calls from companies claiming to be working on behalf of Microsoft, saying that their computer has actually contacted Microsoft to tell them that they have a virus. And this person on the phone wants to help. And if you just go to this website and download this simple-to-use program, it will get rid of the virus for you. Well, if you didn't have a virus, you do now. There's a lot of people who have computers but aren't as informed and get caught up in this. My grandmother actually got hit by a really interesting call. Her phone rang and she picked it up, and there was a voice on the other line and it said, Grandma, is that you?" And she goes, Who is this?" And they're like, "Grandma, I'm in Mexico and my money's gone. I need help. I need you to send me money." And she said, "Mark, is that you?" And they said, "Yeah, Grandma, yeah, it's me, Mark. I need your help." My grandmother went, "I don't have a grandson named Mark," and hung up on him. Which is great. Something that I've told her is getting through. So these attacks can be really scary for people who don't have savvy people in their life who know how to avoid them. So talking about pretexting, we've used a lot of examples, and I'd like to think that I've shown how varied and complex that they can be. They're really personal and elaborate, and that makes them really hard to combat. But the best advice is to be suspicious. It doesn't come naturally, but always be a little suspicious of something that seems off. If it seems weird or too true, or somebody seems too nosy, or maybe they know too much, start asking questions. Be cautious with unusual requests, and verify from a third source where possible. Our next tactic is baiting. This is literally the real-world Trojan horse. Have you ever found a CD on the street, or maybe seen a USB sticking out of a wall, or connected to a mysterious Wi-Fi in a pinch just because you need to check that one email? Well, baiting is literally putting the carrot out and waiting for your target to bite. The CD or the USB are infected. The Wi-Fi is being snooped on, so they're watching your traffic. And we're even now starting to see tower spoofing, which is when somebody puts up a fake cell tower and can listen in on calls, texts, and web traffic of people's mobile phones. Now, it's not even just data at risk. This image has been circulating around security communities for the last probably month. And for those of you who don't believe your eyes, yes, that is a firecracker that's rigged to trigger when the thumb drive is used. The best way to avoid this type of attack is don't pick things up and put them in your computer. You wouldn't put candy you found on the floor in your mouth. So treat your computer with the same thought. So the way that we stop these types of attacks is being aware and having personal vigilance. From a company's point of view, an uneducated employee is the #1 weakness. If we don't give them any education on why we make security decisions, on why we have security rules, then people are going to cut corners for convenience. it's really important to adequately inform employees and get buy-in. HR knows that an engaged employee is more productive and more involved and more willing to go to bat for the company. They're more willing to ask questions. So why do companies fail to get buy-in from their most valuable assets and stakeholders? Well, this is because they don't prioritize security education, or they don't deliver it at all. Other companies focus on compliance with click-through e-learning that's quickly forgotten. And it's really hard to trust users that have subpar training. And sometimes it's down to budget constraints. E-learning cuts training costs up to 60%. Training is expensive. Companies rely on tools to protect and minimize users' interactions with security issues. And that's great from a tech standpoint. I mean, the less spam email I get in my inbox, the better. But these tools don't prepare employees to deal with the attacks that slip through the cracks. So how do we change? How do we move forward from a point of poor education? Well, we need to change cultural thought process. This isn't just an IT issue, it's a business issue. Now, I recognize that cultural change is hard, and that statement deserves its own talk. But we need to talk to employees about why and engage with them on these topics. And sometimes it takes baby steps. We need to ditch e-learning and start creating a space for recurring bite-sized training in classrooms and backed up by video. We need to engage our employees by showing security isn't just for the corporation, but it's for personal use as well. You're going to get spam at home just as much as you're going to get it in the office. And then we should really be following that up with simulated attacks that employees can take part in. Because I don't know about you, but I remember things that I do way better than I remember things that somebody just talks at me about. So we've covered several topics about social engineering and how businesses can improve. We've talked about tailgating and phishing and pretexting and baiting. And we've kind of covered that buy-in requires education and cultural shift. Right about now, some of you are wondering, what does this mean for me? As a developer, why do I need to know all this? Well, being aware and understanding the ways in which hackers misuse social interactions provides us a tremendous opportunity. It's an opportunity to talk to your friends and your family and share this new knowledge. But also, and maybe more importantly, it's an opportunity to look at what you're developing in a new light, to question how it could be misused, and maybe stop a social exploit before it happens. You can become a champion of social engineering education. So that's it from me. If you want to learn more, I would highly recommend that you read these books by Kevin Mitnick and Frank Abagnale Jr. I'd just like to take a moment to thank Web Rebels for having me, and thank you for being a fantastic audience. Thank you so much for your time. Oh, that's right, the sofa.
Yeah, the sofa. Maybe during the next break, I'll steal one of the bean bags, and then it'll be a different seat. That was fascinating. I liked how you used Frank Abagnale as like this inspirational guy. Like,
Yeah.
if he can sneak on to 29 flights to different countries, you can do anything. That was cool. So you talked a lot about social attacks that the tech component is pretty crude and a small part of the effectiveness.
Yeah.
What can we do as developers to prevent? I mean, it seems like the obvious way to prevent it is, like you said, education and fixing the social vectors. But are there technical things that we can do also?
Yeah, I mean, I've come across some websites that have come straight from my bank, and they look like there's something out of the 90s. Like, they just look terrible. They look like an attack. And it's difficult because I'm on the phone with my bank, and they're telling me that this is a legitimate website and that I should use it. And that's fine for me because I'm verifying from a third source. But for others who look at this website and maybe don't question it, they're actually being trained to trust bad sources because of this archaic website design that really needs updated. So I would say that encouraging your company to look at the way that they're presenting all of their website designs and encouraging them to update that and make sure that these things stay in line with the current designs, that people don't get taught to trust bad websites that are crudely put together.
Yeah, that makes sense. You showed a lot of bad things to do that we shouldn't do. Is there anything that we can take from those bad things and apply in a good way? Does that make sense? I mean, like, don't put firecrackers in USB
Definitely
keys
don't
and
do that,
explode
yeah.
people's computers, but like, I guess that's my question. Are there positive things that you can apply these types of skills to? Does that make sense?
Yeah, I think education is really the most important one. Talking to people about these things, and like I said, I couldn't find any examples from Norway, which I thought was amazing. And maybe I wasn't looking
You're
at the right
impervious.
sources.
Congratulations.
But I think that on that front, if it's not something that's found its way here, it's something that could find its way here. Certainly, I know that the types of people who carry out these attacks are always looking for new targets, especially targets that aren't aware of these tactics. And so kind of preparing your friends and family and telling them that these things are happening in other countries and could be something that happens here would be fantastic, because it would maybe stop that risk from opening up as greatly.
Another question I had was around the tension between openness and privacy and security. The web is all about openness and free sharing of information, but we have these bad actors that are encouraging us to kind of clamp down, you know?
Yeah.
How do you balance those two things?
It's really difficult. For a really long time, I had absolutely no presence on the internet just
Sure.
because I was concerned about that very issue.
Yeah, it can be an attack vector, right?
Yeah. So I think it's just important to be mindful of what information you put out in public and what information you use in security settings. So if you put your phone number out there for the world to see, then maybe doing two-factor authentication using your mobile phone number for texting is maybe a bad idea. Or if you have put the name of your first pet or your mother's maiden name or the type of car that you first had out on the internet, maybe don't use those for security questions to reset your accounts online.
If you like tweeted your social security number and got a lot of retweets.
Yeah, exactly. Yeah, definitely
It was very
avoid
popular.
that one.
Yeah, that makes sense. Cool. Well, thank you so much for your talk.
Thank you
It was
so much
fantastic.
for having me. Cheers. Sorry.
Our next speaker is Marcy Sutton. She is a meta web developer, which is a really cool title that you should ask her about. She works at DQ Systems as an accessibility engineer. She loves the outdoors, and she's here to talk to us about JavaScript and civil rights.
Hello. So, respect, diversity, tolerance, collaboration, inclusion. These are values that have mattered not just for our time, but of all time. Hi, I'm Marcy Sutton, and I care about people. I, as Jameson mentioned, am a web developer. I work on accessibility tools for other developers at DQ Systems. I live in Bellingham, Washington, in the northwest corner of the United States. And I'm here to talk to you about JavaScript and civil rights. This is an issue it really matters to all of us. And my hope is that by the end of this talk, you'll learn how you can put your values to work. You can find my slides online at marcysutton.com/webrebels. I will warn you, there's a couple of videos in there, so you might not want to download that on your mobile device. To continue the conversation, you can find me on Twitter at Marcy Sutton. So what are civil rights? They're the rights of individuals to receive equal treatment and to be free from unfair treatment or discrimination. Some aspects of civil rights include safety, physical and mental integrity, protection from discrimination, privacy, and the most slippery of them all, freedom of speech. But there's no room for hate in this list of civil rights. You shouldn't be discriminated from getting a book at the library because of the color of your skin. You shouldn't be killed on a train for standing up to bigotry. So this is about human rights and equality, and I think it's really important to talk about this. This is something that people have talked about a lot in the past, but it's still important today. Civil rights are about equal protection under the law, and it's important to remember that people have fought for this. In the 1960s, people picketing in New Jersey for equal rights in housing, these folks had moved from the South where racism was in their faces, segregation. They had to explain to their kids why you can't drink at that water fountain or we can't go to that restroom. And they moved north hoping that it would be different, but the racism was a bit more subtle, and they still had to fight for those rights, and it definitely still exists today. Another example of people fighting for their rights are thousands of women marching through Manhattan demanding equal jobs and educational opportunities. This photo is by the American photojournalist Betty Lane. A bit more recent, people protesting outside the European Parliament in Brussels. The European Disability Forum was marching for stronger accessibility legislation in the EU. Nothing about us without us. To give people more freedom of movement, barrier-free environments, and have that backed up by the laws in the EU. So we have a responsibility to protect our users' rights to accessibility, access, safety, and privacy. And there's more aspects to this, but these are the things that we'll cover today. And then there's JavaScript, this ubiquitous programming language that's deployed nearly everywhere. It's pivotal. It can take an old school synchronous interface and make it more modern and asynchronous. It's sort of the pocket knife of developer tools because of how powerful it is to transform these interfaces. So today we'll talk about how JavaScript can apply to our users' accessibility, safety, privacy, a little bit of security, and when you pull all these together, they can improve people's freedom. Something very important. So let's start by talking about accessibility, a passion topic of mine because I care so much about people. Accessibility is about freedom from discrimination. It's about being able to have freedom of movement and independence. If you think about someone with a visual disability being able to do their own online banking without having to give their PIN number to someone else. That's really what accessibility is about, and it extends beyond the digital world into the offline world. In Norway, you have great universal design laws that really this idea of accessibility is about barrier-free environments so that someone with a disability can live an independent life and do their business with freedom. And a good example is getting on a bus if you're in a wheelchair. You need a ramp. You need to be able to get around in the world. And in reality, it's not always that places are accessible, but we collectively have the opportunity to make that better in the work that we do. So in web accessibility, the digital part of this, it's really about removing barriers. And I think sometimes people don't realize that they're putting these barriers in place by not thinking about accessibility. So I want to encourage you to learn about it. And if you're just starting now, that's great. We can iterate, we can make it better with every little change that we make for accessibility. It's so appreciated. So hopefully you'll be able to take that away from this talk. So disabilities, who are the people affected and what is this about? If you want to read more after this talk, there's a great piece by webaim.org, their intro about the people who are affected. People with visual disabilities who might be born blind or have degenerative vision loss, what we call low vision, and then people who have color blindness, having bold contrast and colors that actually have text labels on them. That's one aspect of accessibility that people might need screen readers or high contrast designs. People have hearing disabilities. You might be born deaf or have hearing loss, and as a result, you need transcripts, closed captions, and alternatives to this rich media. There's people with motor and physical disabilities, someone who maybe can't use a mouse and relies on the keyboard, so you need to see where you are on the screen, and things need to be operable for the keyboard. I don't know about you, but I really like navigating with the keyboard. My overuse injury with my elbow, it was really important to be able to switch it up and not rely on a mouse. And people with other physical disabilities, like maybe you have vestibular disorder and motion just makes you sick or gives you a seizure. And there's people with cognitive disabilities. You might have a learning disability or a traumatic brain injury, and maybe you just need simpler language and easier to use interfaces. It really could be you. So if you don't identify with these groups quite yet, it might affect you later in life. And there's a really great toolkit from Microsoft. The Inclusive Design Toolkit has some ways to think about accessibility and how it matters. And one way is that you might have a permanent disability that you're either born with, or like a friend of mine who got in a bike accident and is now paralyzed. It could happen at any time. You could have a temporary or situational injury, like an arm injury. My elbow flares up all the time. You could be a new parent and have a baby in one arm. So situationally, you don't have the same interaction with your computer. So it's important to really think about it as it affects all of us. So that we're all invested in this idea of accessibility. So what I like about accessibility is that I can put my values to work and really help people. And that's so powerful. So I hope that you can be encouraged to pick accessibility up in your day-to-day work, because you have the power to make the web more accessible. And I have to be honest with you, the web is not the most accessible place, for as much as I like to talk about it. So that's why it's so important, and why I'm talking to you about it, is because each one of us has the power to make it better for the people in the world. So let's look at an example of some poor accessibility. The website virginamerica.com a few years ago was launched as a new shiny Angular app, and it was touted as having very slick user experience. But if you use a screen reader or even just a keyboard, it became quickly obvious that they hadn't thought about all of these interactions. So I'll play a video using the voiceover screen reader on the Mac.
Link, more. Internal link, Virgin America. Link, book, list 3 items. Link, check-in. Link, manage. Link, deals, list 6 items. Link, flying with us. Link, where we fly. Link, fees. Link, flight status. Link, flight alerts. Link, sign in. Link, sign up. Internal link, Seattle. Internal link, LAS Vegas NV, LAS, list 6 items. Internal link, Los Angeles CA, LAX.
So I hit the enter key, and the window
Internal
scrolls.
link, San Diego CA, San. Internal link, San Francisco CA, internal link, Washington DC/IADC, IAD. Internal link, all cities. Internal link, 1, list 12 items for sublists. Internal link, ADD, list 2 items level 2. Internal link, subtract.
Okay, so it keeps going. There was a number of issues there that you may or may not have noticed. The first issue was that there were radio buttons at the top for round trip, one way, and multi-city, and they weren't real radio buttons. They were probably coded as divs, so we couldn't reach them from the keyboard, nor would a screen reader user reach them. The next issue was that focus management was not handled. So when the window scrolled and then I hit tab again, we jumped right back to the last section. So our focus was not forwarded on. And as we interact with this interface, these issues came up again and again. The control that we're looking at right now to add the flyers onto this reservation, each plus and minus button is not unique to that section. So if you're on an add button, add what? Subtract what? We don't know. We have to put these unique labels on each of these buttons. So I'm happy to update you that since that, in 2014, they've done a lot of work to make this website much better. And Virgin America has been acquired by Alaska Airlines. This website has been improved greatly, so I want to show you what they've done with it. we will see if this version has audio. Okay, so this is the keyboard version. So there's a skip link now. That's a big improvement. And what's happening in the user interface now is that they have made everything reachable. So the window is visually scrolled, but those radio buttons were reachable now. And if I type into this field to change the city, it will actually send my focus on to the next area. So if I go down there, it focus is forwarded. There was also a banner up at the top that when it selected the city that I chose, it announces that in the screen reader. And so iteratively over time, they made this website way better. And it means that someone with a disability can actually book an airline ticket on this website. Whereas before, they would have just lost their business. So you're really losing customers by not caring about accessibility. So it's really great to see that get better over time, and that's what I want us all to be more aware of. So some UI considerations. If you're building an interface that humans use, which most of us do, you must write accessible HTML. If you're delivering HTML with JavaScript, it's the same basic story. We have to learn a little bit about how HTML works. So I'm not going to cover that, but that's an important consideration. Keyboard support, you need to be able to reach everything. You need to see where you are on the screen. Similarly, but not exactly the same, is focus management. So that issue that Virgin had where my focus wasn't sent, but the window was scrolled, we have to make sure that we're actually in the right area. Localization, if your users are from different locales, we need to make it a bit more personalized for their understanding of the content. And then lastly, screen reader updates. So the banner up at the top at Virgin America, when they fixed it, it actually announced what I booked. So as a screen reader user, if things are happening elsewhere on the screen, I can be notified with something like an ARIA Live region. That's a great tool for that. So something, if you're making an interface and trying to support the keyboard, start with elements that are focusable by default, like a button element. With a button, you can put a click handler on it, say for a close button in a modal window, and then you can bind a click handler to this element. You get a lot for free, so it's focusable, it has a button role, and I can use the click event because it's a button. In contrast, if for some reason you can't make a button element, this is all the stuff that you have to replace. And I think often people will just put a click on a div, and if you do that, the hair on the back of your neck should stand up, and you should go, wait a minute, how do I reach this from the keyboard? To do that, you need to add a tab index. I'd recommend 0, not positive numbers, because then you have to manage all of the tab index. You need a role of button to tell a screen reader that it's a button. And then that click event will not actually fire from the keyboard because that's not a natively interactive element. So you need a key down or a key press or something like that, and then you have feature parity. But you had to do a lot more work. So I would recommend starting with the button. So if you're not familiar, there is a set of standard attributes in HTML to specify accessibility information. It's called WAY ARIA, the Web Accessibility Initiative's Accessible Rich Internet Applications. And there's 3 components to this. The role, which is what does this thing do? And I have an example of a custom checkbox. Now, I only tell you about this because it's an advanced tool. I think we like to learn about some advanced things, but you should definitely start with an input element, input checkbox, because you get all this stuff for free. But the role will allow you to specify the type of an element. You can use an ARIA state, like ARIA-checked of true or false, to try and replace that checked attribute that only works on a native input element. So ARIA-checked is, what state is it in? Or ARIA-disabled, is it disabled? And then a property is what's the nature of it. An ARIA label is a good example. You can use ARIA label and then a text string to specify an accessible name for a custom control. Now, a custom control could be a div, it could be a pizza button or a pizza checkbox. Maybe you don't want pizza, so you uncheck the checkbox. But this is only an advanced tool that you reach for after you have exhausted all of the native options. So something that might help you if you're doing this accessibility stuff. We didn't always have tools to help us debug it, and when I started with accessibility, I got it wrong. It happens. We're human. So now there's a really great debugging tool in Chrome that you can enable. It's currently behind a flag, so you have to turn the experiment on. But once you have this, you can inspect elements just like you would inspect styles. You can look at the role, if it's disabled or if it has an accessible name like a search. And that is a missing tool that we have needed for so long. So I'm really excited to see that land in Chrome for real very soon. But you can enable it. I have some instructions on bit.ly/chrome-a11y. So to get accessibility, so we're not having to make these fixes over and over again, we want to make sure we don't break stuff, right? So testing is a really great place to introduce accessibility. If you're doing things with focus management or keyboard support, you could write unit tests with headless Chrome would be one way. You can also write more integration-style tests with Selenium WebDriver. And I have a test here that is for a bottom sheet in Google's material design. And in my before each, I find an element I click on it to initialize the bottom sheet so it's open when I run my test. And then I can assert that it should focus on the first item. And the details of how you write your tests isn't as important as testing that the functionality works. Because then if for some reason another developer on your team breaks a feature and they didn't realize what it was for, you have test coverage for accessibility. And that's really powerful. So this is one example of how you could write a test in your application that's specific to the code you've written. So another tool that you could reach for is something that I work on at DQ, the AxeCore library. You can find it on NPM. AxeCore is a JavaScript library that has a bunch of accessibility tests that save you from having to write them, which is something I went there to learn about. There's a lot of little nitty-gritty details that we keep track of in AxeCore. So to pull in Axe, you can do npm install AxeCore, and then you have these API methods like axe.run, and you can pass it a document reference, an element selector. You can either run it at the page level with the document object, or you can get more specific and tell it, hey, only look at this component. You can pass it any number of options, and then with a callback function, you get, if there's any errors, you can listen for those, and then it gives you this results object. It's a JSON results object. It has an array of violations, passes, incompletes, and inapplicable. And in a test, that's really great, because you can say, I expect that there are no violations. You can say pass fail, and have it fail a build if it ends up regressing or breaking something. Another tool that you could use Axe with is if you do have WebDriver tests, you could use Axe WebDriver.js, which is also on NPM and on GitHub. And it's very similar to an Axe, just using axe.run, except that the Axe builder will inject Axe into the browser instance for you, including iframes, which is really useful. And then when you get this, you run the analyze function and pass it a callback function, and it gives you that same results object. So that results object, you can look at our API documentation on GitHub, but it will find things like ensuring buttons have discernible text. Let's look at another example. It'll find iframe elements if they are missing a title attribute, or if the HTML element is missing a lang attribute. It'll find alt text that's missing, so that's a pretty basic thing that it's nice to just have a tool look at that for you. It'll look at form labels, color contrast, and the list goes on. You can see our entire set of tests on GitHub. But that's really powerful because you programmatically can test for accessibility and not have to write the boilerplate of these tests yourself. So to learn more about AxeCore, you can go to our brand new shiny website at axe-core.org. And that has all of our integrations. You can learn more about how it works. We have a Gitter channel that we monitor as well. So that's one tool and a set of things that you can do for accessibility. But that's just one aspect of civil rights. So let's talk about safety. Another important aspect so that people's civil rights are maintained in any applications that we write. You may have known about an incident that occurred last December where the journalist Kurt Eichenwald was sent a tweet containing an animated GIF, and it induced a seizure because he had epilepsy, I believe. He's actually brought legal action because that is considered a deadly weapon. And the tweet back to him said, "I hope you get a seizure." So the intent to cause harm was pretty clear, and they could bring legal action against this person. I'm going to show another example, a bit of a motion sickness warning. If you have vestibular disorder, or like me, when I first looked at this, I was a little hungover, and it made me sick. So this site is called narrowdesign.com. It was going around the web a couple of weeks ago, and it was a really interesting interface that was pretty new, in that when the pages change, they totally rotate. And there is a little warning that says, do not proceed if you suffer from vertigo or you just hate experimental interfaces. And the link sent you off to a PDF-style, just plain page of each of these, which is a little bit of a bummer. Because what we could do instead, that, admittedly, that is a warning and an affordance, but I think we can do better by providing affordances to give users the ability to turn animations and motion off. So if you do get issues from these, give the user the control to change it and turn it off. But on the Narrow Design site, for example, we could have used the prefers reduce motion media query, which just landed in iOS and OS X. So there is now a media query, and you can use match media in JavaScript to change the way that your animations and motion work. If the user has enabled this setting, it's under accessibility on iOS and in OS X Sierra. With that enabled, you have a hook in Safari to actually turn these things off. So that is super powerful, and you can read more about prefers reduce motion on the WebKit blog. So what that does when you turn it off, I have reduced motion turned off on my phone, and it gets rid of parallax in case that makes you dizzy, and it just sort of fades more gradually. So that's a hook that we can use to actually customize the experience. And I want to nudge other browsers to implement this, because we want this everywhere so that users can choose which browser they're in, but then still have this power to change our interfaces. So the story with Kurt Eichenwald and the GIF, Twitter has now at least added the ability to remove autoplay, so it's not quite a weapon anymore. But Giphy is another example of a lot of flashing content on a screen. And they actually have an autoplay toggle on their site, and it only works for the GIFs. It doesn't work for videos on the canvas element. So to turn that off, if you absolutely needed to, because Giphy, yes, we're going to look at GIFs specifically, but these are applied all over the web. So as a user, you could use an extension like GIFJam, which I found in doing research for this talk. GIFJam is written in JavaScript. It's a Chrome extension that you can use at the browser level to turn off all kinds of animation. And if you wanted to implement something similar, you could look at how GIFJam works. It gives you a little stop play button, and once the current frame of a video on Canvas element has run out, it will just show the first frame of each of those videos. So that's a tool that you could use as a user. You could take advantage. You could recommend to your users, or look at how it's implemented and implement similar things. And it's worth reiterating this tweet from Tasha's EV on Twitter. She says, "Dear every web developer in the history of ever and all the future to come, don't autoplay anything ever." And it's tempting. You know, we have marketing saying we really want an autoplay video that covers our entire interface. And that's really problematic if you get nauseous and you're just trying to go to your bank website and there's an autoplay video. And you can read more about that on the a11yproject.com. Something really interesting I saw just this week was that the Brave browser actually has a setting at the browser level to turn off animations and autoplay media. And it works on CNN, which is one of the most glaring in-your-face autoplay examples. So that's really cool, and I hope other browsers follow suit. So that's a bit about safety. Let's talk about privacy. As I was researching for this talk, I read an article on theguardian.com, and all of a sudden there was an autoplay advertisement with a video. I guess they had targeted me as an active woman who likes yogurt. And in the next 5 minutes, I saw the same ad on Instagram. So they have definitely targeted me and were pushing these ads at me, but I couldn't turn this, like autoplay just plays. I can't do anything about that. So this is sort of the safety and the privacy together. So a little bit creepy. So websites leak our data. We are often complicit in this as well. There's a really creepy article on cbsnews.com about the data brokers that sell your personal information. They use tracking cookies, some anonymous, some not, ad networks that measure your behavior. And I saw Google Analytics was pushing their universal analytics, which is hoping to identify users across their devices. So that's identifying information. And they're really building a profile on you, on each and every one of us, to try and target advertising. They say it's to make it more useful to you, but it feels like a violation of privacy. I was complicit in this. Until this week, I had the Discus plugin for WordPress on my website. The intent is to make it easy for you to log in once and then be able to comment on all these sites without having to create accounts. The problem, and I'll play this video, of my web page loading, you can see how many third-party assets are loaded by Discus, some that I did not sign up for. I mean, I guess I did by using this tool, but I wasn't aware that it was using all these things. So it's tracking every single user that comes to my website. Like multiple, I think there's 4 domains that load these top-level resources, and then those fetch other third-party resources. And so I have since removed Discus from my website. Fortunately, that plugin in WordPress puts those comments in your database, so I can present them using the traditional WordPress comments. Still working on that a little bit, but at least Discus is no more. So if you're using it, this is what you've signed up for. So free software often means that you are the product. Not always, but most of the time. And how many times do we not read all the way through the terms of use? And our users probably don't either. So this is something that we need to be more careful about when we choose these tools. I found an interesting take on this on NPM. There's a package called Subvertise that was made in response to, in the United States, they recently repealed the privacy controls where your ISP can't sell your data. Not getting into that too much, but this tool is actually an Electron app that will spin up in the background and visit random sites to muddy up your history so that what they're selling isn't actually as useful. So pretty subversive, and I thought that was an interesting thing. It definitely uses up data, so if you have per megabyte data, you probably don't want to use that. Another tool called Sheriff, this one is, I could see using this one a bit more easily. The official code sharing snippets from Facebook, Google+, and Twitter, they quietly siphon your users' personal data. Facebook is watching every user that uses this like button across the web and then using that to sell advertising. These buttons, share buttons, aren't implemented the same way. So if you wanted to provide a useful sharing button to your user, you could do it a bit more responsibly so that you're not just leaking their personal data. Websites can track us. They may or may not take advantage of this, but any site that you visit they can use JavaScript to track what you type. It's a little creepy, but that's just kind of the way the web works. So if you are bothered by that, the building of your profile, there's a Chrome extension that Naked Security made where you can actually have it sort of obfuscate how you type and make it more difficult for these networks to build a profile on you. Now, if you think about that and how creepy that is, think about having a disability or some issue that might impact how you interact with the web. In the last few weeks, my friend Leonie Watson, who's blind and uses a screen reader, tweeted, Facebook was using educated guesses to trap people into confirming they have a disability. Now, Facebook doesn't actually know that she has a screen reader because there's no way to track a screen reader. They made educated guesses and presented a survey so that then the user would take the survey and say, yes, I have a disability. This is problematic to a lot of users with disabilities. As tempting as it is to want to, but I want to personalize the experience and try to get better at accessibility, most people with disabilities do not want to be tracked. They want to be able to freely move around the web. And another example is this article by Marco Zija. He's written about why screen reader detection on the web is a bad thing because it's like waving a white flag and saying, "Hi, I'm disabled," where otherwise it's the one place they can go relatively undetected on the web. So if we're using this tracking, there's so many ways this could be used against us or used against our users. You could have an employer not hire you because they think you might be getting pregnant soon. Like all of these ways that you could discriminate, and people with disabilities are sort of on the forefront of this issue of not wanting to be discriminated against. So here's one thing you can do if you're trying to make the case for accessibility. You can't track screen readers and users with disabilities for obvious privacy reasons. But if you are trying to get a little bit more metrics on how people use your site, this isn't specific to people with disabilities, this is more general. You could use analytics to measure accessible events. So if you have a menu and it has keyboard support, you could use event level tracking to actually measure if people are using that in the way that you're expecting. Now, I will also add an asterisk here that if you are using Google Analytics, by signing up the terms of use, you actually are obligated to have a privacy policy and a way for the user to opt out. I was not following that until yesterday, I will admit. And I've been using Google Analytics for years. So I learned a lot in researching for this talk, and I have a privacy policy now. But that gives users a way to understand how you're using their data. It's anonymous. It tells them, or tells you how they got to your site, what content is relevant. So if you want to know, what mobile device they're on so you can make the design look better for them, I think that's a fair trade. But you should notify users that that's what's happening. And a privacy policy is good for that. So to recap, accessibility is a civil right. I think that was an important line to draw in the sand for me this year because it really took it beyond just accessibility is the right thing to do, and it's really about human rights and equality. Safety and privacy are wrapped up in this as well because these are all interlinked. Honoring our users' rights to privacy and access and security and all of these things, it's about making things that treat our users with respect. Our work really impacts people's lives. I often have to say, who are you designing this for? It's not for ourselves, even though in this aspect it sort of is. These are all concerns that affect every one of us and our friends and family, our customers and our users. We impact people's lives with the things that we build, so let's try and do right by them. So we can make a difference, and I hope that you will. Thanks so much for having me. That's it.
Great job.
Thanks.
So, it's careful.
It's cute, though. It's a cute couch.
It's precarious. One question that an audience member had is, you brought up screen readers and you showed an example of that was the Mac OS screen reader, right?
Yeah, VoiceOver. Which, if you have a Mac or an iPhone or an Android device, there's lots of screen readers.
Yeah, they kind of have the same issues that cross-browser development had, though, right? Don't they all behave a little bit differently? Is there some kind of service like Browser Stack, but for screen readers, that will allow you to test your website on a bunch of different screen readers without needing to have them all installed, or is it?
Not yet. I've heard people asking Browser Stack for that. The challenge is that screen readers you can't program them to operate like Selenium WebDriver. It's possible, just no one's done it yet. So with VoiceOver, theoretically, you could do it with AppleScript. With NVDA, which is a free open source screen reader on Windows, theoretically you could do it, but no one's done it yet. So that would be really useful. Because part of the challenge is that unless you're a proficient screen reader user, you might not be testing it in the way that a user would.
Yeah. So there's a lot of domain knowledge at like the technical level and also just the user level, it sounds like.
So yeah, I'd say that's, somebody wants a good challenge that could potentially be a business. That would be really incredible. That's kind of the next big thing that I think we need to get better at.
Free startup idea.
Yeah.
Sorry if I gave away your startup idea to several hundred people.
It's for the good of all of us, so that'd be cool.
Someone said a nice thing. I'm so glad Marcy Sutton takes Web Rebels beyond JS and touches on accessibility matters. We need to be better at this. thank you for saying nice things. That was great.
Oh, thanks.
Another question I had is your talk was very motivating to me as a developer. I work in a commercial context, which is less motivated by things like being nice to people and civil rights and more motivated by money. How do you work within a business like that to help them prioritize this?
Yeah, it's really interesting. It sort of depends on where you live. In the US, the legal risk is a big stick. And in the EU, and more so here in Norway, it's more about the carrot and doing it for the good of people. It's sort of a cultural thing to try and make sites as clean and hygienic and bug-free. It's about quality to a lot of people. But I know in the US that legal risk is very important, and that's why the legislation, like accessibility is inherently political, because the laws are very important to get people to do the right thing.
Sure.
So yeah, it can be challenging, I guess, depending on what tier of business you work in. Sometimes it's motivating to say you're losing customers. People who are blind want to buy stuff just as much as other people do, so you could take that angle. You could make it about quality. I think that's a good way to reach developers. And it's important to remember that you can start small. Like every little thing that you do is so appreciated. So try not to get overwhelmed by it and just start iterating each feature you touch. Try and make it part of your definition of done. And that's how you can kind of just do it over time instead of trying to fix it all at once. That would be daunting.
Yeah. Another theme, I feel like I've seen you talk about this at other talks and this one as well, is how you make complex JavaScript apps accessible. It seems like one solution is don't do them. And if you just render HTML, that's pretty accessible by default. But how do we wrestle with all these rich, single-page applications and making those accessible?
I think there's definitely ways to do it. And like the narrow design example, I think that we can use these tools and really lean on browsers to give us these tools so that you can make it personalized. I think it's challenging to make something that works for absolutely everyone. So making it look good in high contrast mode, or making it zoom so that the user can change it. Those are some examples, but in a JavaScript app, there's some basics that you just need to be aware of if you're doing these single-page apps, like focus management and announcing things to screen readers. And I wrote an article called Notes on Client-Rendered Accessibility. If you're interested in that, it's on Smashing Magazine. That was to try and document the things I'd learned on the Angular team about like how do you make that accessible? Because it is possible. Mm-hmm. We just need to, it's something we need to know about, along with security and privacy, those kinds of things.
Sure. It seems like it's, right now it could be looked at as a niche skill set, and the goal is to make it not niche. It's to make it like, CSS, accessibility. Is that a good way of putting it?
Yeah, definitely. And that's why testing is a great place to kind of like get it in the door. And to try and document it so that you don't have one person on the team who's like the only one that knows.
Yeah, and then they're like the nagger whose job it is to get you in trouble. Like, you did this wrong.
Yeah, and you, as that person, you have to keep like on top of everything, and that's just not possible.
Yeah.
So it's really helpful to kind of bring people along and make it everyone's job, not just one person, because it's just frankly not going to be successful if only one person is doing it. I mean, it even goes back to design. Like I focus more on development, but it really starts with UX and design. So it's everyone's responsibility.
Sure.
And it can be really cool. Like that's what I think is so exciting, is that it doesn't have to be basic HTML only. You can make these rich applications that are going to end up more useful for everyone. It's like when my elbow flares up, I just don't want to go anywhere near a computer, because frankly, it's pretty bad out there.
Yeah.
So that's why I think each one of us, each website we build, we can improve this situation.
Yeah, that makes sense. Great. Well, thank you so much for your talk. I really enjoyed it.
Thanks.
Give Marcy one more round of applause. Good work. So it's break time now. We will see you all back at 3, right? Yeah, come back at 3. See ya. And you were all right because you came back at 3:30. So thank you for being smart. One announcement, if you've seen by the entrance, there's the bins with the water bottles, which is awesome. So we can bring water in here, we can reuse those. They don't have enough water bottles for everyone to get a new one tomorrow. So if you have a water bottle, try and keep it and reuse it tomorrow. If you don't, it'll probably be okay, but just try and reuse it so they don't have to run out. That would be great. Our next speaker is Charlie Gerard. She is a creative coder, a software developer, a hardware tinkerer, and she's here to talk to us about a unique input method for JavaScript. Please give her a round of applause.
Thank you. Do I have to do this? Right. Okay. No. All right. Okay, cool. So the topic of my talk today is mind control in JavaScript. A little bit more about me. I mean, I've already been introduced, but I hide photos of myself, so that's like my spirit animal. So yes, I'm a creative developer at the New York Times in London at the moment. So what I focus on is like working on animations and interactions to make our marketing content. So I'm not part of the news section, I'm part of the advertising section. So all the pieces of branded content on the side, I work on trying to make it a bit more interesting for users to read. Before that, I was a software developer for a couple of years at ThoughtWorks in Sydney, so working on quite different stuff. But mainly, I just like to make stuff. I like to build things. I like to try and use technologies in ways that are a bit unusual and a bit more creative. So I usually, like all I do is pretty useless. It goes from like shitty robots to like prototypes of art installations that don't really do anything. But as I spend a lot of my personal time doing it, I like to just have fun with that. So what this talk is going to be about, so I'm going to explain a little bit more about how I got to tinkering with the brain sensor in JavaScript, the tools that I've used, some code samples that I'm going to try to explain. I'm also going to try and do some live demos. I'm saying try because I know that something that I wanted to show is not going to work, so that's great. I already know it's not working. And some resources, which is probably just links. So how it all started. So I actually don't have a background in computer science. I studied marketing because at the time I thought that programming was just for like really, really smart people and I couldn't do it. So I started as a digital producer in an agency, and then I was working with a team of devs and I was really interested in what they were doing. So I wanted to do it myself, but learning like on the side after work is something that I found really difficult because I didn't know at all where to start. So I did like one of these quick boot camps where you kind of learn to be a programmer in a few months. And while I was looking for my first job, I had these two devices. One of them was Sphero robotic ball. I don't know if you may have heard of it because they released the BB-8 version for Star Wars. So you have this little robot. And I also had Leap Motion, which is a device that you plug in your computer and it recognizes hand gestures. And I saw that both of these devices had JavaScript frameworks available. So what I did is that, so this is me in my old apartment in Sydney, and I worked on trying to control the Sphero using my hand movements over the Leap Motion in Node.js. And this was the first thing that I did using hardware, and I was like, well, this is exciting. I can just use JavaScript to control actual things. Like, there was nothing happening in the browser at all. So it doesn't do much. Yes, it like goes left and right. And, but it was still really exciting. It's like just a movement with some code that I wrote, and I can just make stuff move. So as this was my first experiment, I was like, well, what is next? What can I do next? So then I bought a Mayo armband, which is the device that I'm wearing on that photo as well. And what that device does is that it gets some data, like EMG data from your arm, and it also has some kind of pre-built movements, like swapping right or left or something like that. And you can apply that as well to an interface, like on a web page, or to hardware as well, because as the code for the Sphero, to control the Sphero was already done with a Leap Motion, I just had to replace it with using a JavaScript framework for the Mayo as well. So yes, all of this was also in Node. And then again, I was like, well, what's next? So I bought this device, which is a NeuroSky. So it's a brain sensor, but a pretty simple one that has maybe like 4 sensors on it. And it can track levels of attention and meditation. You have access to raw data as well, but like I know nothing about neuroscience and stuff like that, so I couldn't really do anything with the raw data. But at least I played with levels of attention and meditation. And same again, I was also able to control a Sphero and a drone just by trying to focus. The thing is, it's a bit flaky, like it's not working very well, so sometimes so I could have a drone take off by focusing, but if it doesn't detect that I'm calming down, then the drone just doesn't land, and you have to wait until it crashes. So, which happened quite a few times. But yeah, I mean, like, so I was quite excited, but yeah, as there's not that many sensors and the data is not very accurate, then I saw this device that I'm wearing on my face there. And this is called the Emotive Epoch, which is the one that I have here, that has 16 sensors all over your head. So that's a lot more data and a lot more things you can track. But I will talk about that a bit later when I do the demos and stuff. So when I bought this device, I actually didn't check if I had any frameworks in JavaScript available. So I had a bit of issues because the only SDK available were in C++, C#, Java, Python, and Objective-C, which is like stuff that I don't know at all. I mean, I know I have a bit of knowledge of C++ because I played with Arduino and a tiny bit of Python as well, but really not enough to be able to understand the SDK. So that was a problem. And also, there's not many resources available. This device is quite expensive, so I totally understand that there's actually not many people who have it. So the amount of tutorials or anything is kind of like none. But the problem is that I had this device, and I paid quite a lot of money to try stuff with it. So I didn't really want to give up, and I was like, well, let's try and create a JavaScript framework. Let's just try to make something. Let's try to do an interface where if people have this device, then they don't have to go through the whole struggle that I did have to go through, and they can just get all the events in JavaScript and do stuff with it. OK, so the tech stack that I use. So I picked the C++ SDK. And then I used these 3 tools. So you have Node-GIP that allows you to compile native add-ons for Node.js. Then you have Node bindings that allow you to then load this native add-on. And NAN, or NAN, I actually don't know how you say that. But it's making like native abstractions in Node.js. I'm not exactly sure how to explain these in more detail, so I just try to write one sentence that makes sense. So please don't ask me like super technical questions about these. I just know that I've used them, and it works, and I'm going to try and explain some code samples, which is going to be hard enough. Oh, yeah, OK, code samples. So here's just a hello world example. I am not a pro at C++, so I'm going to try and do this. Like very simple stuff, hopefully. So I have a hello.cc file. And there is method that is just logging hello world. And then I have my method init that is going to export a method called hello that is going to call the first method, I think. And then the last line is actually doing kind of like making it available as a module called module that calls the function init. I try. OK, so I think that's what it does. And I just know it works. So, but I think that's what it does, because then after this, you have your binding file where the target name is module, or yeah, actually it didn't help that I called my stuff with really shitty names. But so our module, that is called module, then all the code that is going to be bundled is that the source comes from our hello C++ file before. So you run your little node git rebuild. I think there's a task called build, but I just always rebuild. And then it allows you to have in your JavaScript file you require using node bindings, a module called module. And then you have the function hello that we exposed before. And when you do node test.js, you have your hello world console log, yay. So basically, you see that you can go from C++ to JavaScript in 3 steps. Of course, the hello world example is like very simple. So like if you want to do more complex stuff, it's going to be a lot harder. But it's still really cool. Like it does work. And I think there's also like a node add-on examples repo where you can try a few different things, like passing arguments, and see how that works. But for someone who doesn't know C++, that's actually quite exciting to get started with that. OK, code samples of what I did with the Emotive. So let me try and explain as well. So the Emotive, the SDK, has some functions like emo state create. So you can get, so it checks kind of like the data coming back from the sensor, and it tells you if you have a blink action or thinking of pushing or whatever. So then you have a variable called event. I'm not actually sure how to explain this. But then you have functions like expressive is blink, and you get the state, and it returns 0 if you're not blinking, or it returns 1 if you're blinking. So then you have You have other stuff like expressive is looking left, expressive is looking right. So once you have one thing working, you can just do the exact same thing with the other states that you can get. And then with our user.isBlinking, we have like that here, and we expose it as a .blink. That's the best I can do. And then, so same with binding.git, we expose our module with the name index, and we just a few different files that are going to be bundled with this. And then in our main.js, we require our module, and I did have a function connect to start all the events. But then we can start, like inside this function, we can have access to blinking, thinking, pushing, pulling, dropping, all the stuff that the epoch gives you. Oh no, okay. All right, so as I said, I already know that some of the stuff that I wanted to show is not going to work, but I'm going to try and show the rest. All right, so let's start with the emo composer. So I'm probably going to have to, do I have to exit? No, oh yeah. Let me just, where did it go? Oh, no, not this. Wait. All right, can I, oh yeah, I just need to exit that. Okay. And emo composer. Okay, so when you start building a program for the emotive, you have a software called the composer that's actually an emulator. So if you can't be bothered to set up the whole headset on your head, because it can take a bit of time, you have access to all this, so it kind of emulates as if the headset was totally well connected, and you can send all the actions that are available on the sensor. So I think that, okay, so if I do, all right, so I either have access to the live events from the sensor if it's on, or I can connect to the emo composer. So if I connect to it, then I can say, oh, let's just check if my blinking action is working. Oh, yeah. Oh, actually, wait, let me make it bigger. Ooh, not this. Let me try again. Oh, no, because, yeah, I know. So if I do this push and I give it a little power, oh, there's neutral. But there's push as well. So it's not totally fully working, but I think if I do this, all right. So you can track a few actions. So on the left in the terminal, you have my program in Node, and on the right, you have the kind of like emulated commands. I did have a backup video in case it didn't work, but that's fine. We shouldn't need that. So then, the mental commands. So this is another tool that you can use that is called the control panel. And that works with the live feed from the emotive. So at the moment, it's not connected. So while I try to set it up quickly, I'm going to play this video that's going to loop, so you actually have something to look at while I get ready. And because the thing is with that brain sensor, actually, I'm going to loop it, and I'm going to try and talk at the same time while I try and set it up. So what I was doing here is I was trying to I was training some thoughts about thinking left and pushing and stuff. And you have the feedback in the 3D cube that you see there. You can also test your facial expressions and things like that. And what I'm doing right now is that all of these sensors actually have to have some gel on it, the thing that you use to on your lenses. I don't actually wear lenses, but yeah. So for them to conduct properly, like on your head. Oh, actually, I'm making a mess. But all right. I actually got stopped at the airport because I had that in my bag, and I thought it was because the headset maybe looked weird, but no, it's because this is more than 100 mils. So I was just like, you guys are weird, like seriously. So I actually had to get rid of the bottle I had, and I had to buy another one. But so I hope this one works kind of well as well. But I don't know, I just found that very weird. I was pretty sure I was about to be like, oh, I swear I'm talking at a conference, like it's not weird. But no, not even. Okay, I think I'm good. All right, I'm going to try and put that on at the same time as the microphone. Oh, all right, wait. Where is this? Okay. Let me check if it's... Okay, there's like a USB dongle, and then I turn it on. Turn on. Ooh. Oh, that's all right. That's actually pretty good. I never have that. Ooh, almost full green. All right, so... That's it, I'm done, bye. All right, so you have mental commands. you're going to have to be like, I don't know if it's going to work because all I'm thinking right now is like, don't let me down, don't let me down. So I'm going to have to be, that's going to be very weird. You're going to have to really look at this because sometimes it takes just like half a second and you can see it's like, oh, it worked. All right. I feel so stupid. I don't even know. Oh, wait, it crashed, that's why. Why did it crash? Let me just turn. Wait, you can see there that it's not connected anymore, and here, the timer just like stopped. Let me quit. Let me start over. Hello? And stop this so I don't need this anymore. Is it on or off? I don't know. Come on. I don't know if I turn it off or on because it's behind me. Okay, that's all right, that's pretty good. Let's just try facial expressions. So that's the only avatar you have, like a kind of bald dude. You don't have a woman, so it's like, woo, look, I'm moving my eyes, and I'm not actually smiling, but okay, hey. So yeah, that's why it's like, it doesn't always work, but if I do like this, like, oh, yay, big eyes. Let me try again. Okay, don't crash this time. Of course, okay, well, oh wait, wait, something moved. No, okay, that's the signal. Wait, I'm just gonna try. 10 seconds. Totally letting me down. All right, but I have a video, like, look, it did work. I promise, I swear, I'm not lying. Yeah, look, it did work. Okay, so it doesn't work all the time. But that's fine. So the only problem with this is that these mental commands actually don't work at the moment in JavaScript. And I thought they did because when I use the emo composer, I can send the events and I get it in Node.js, so it should be working. Oh, my hair is everywhere. But the thing is that I also check in, so there is something where you can, actually, I'm going to show you a little bit more because, what am I doing? Because the way it works is that you actually select thoughts that you want to train for, and you think about that thing for 8 seconds. So it has to be thoughts of actions, because I guess it's a little bit easier to detect. So here you can see that I trained for thinking about pushing, pulling, and the direction left. And when I'm in my C++ code and I try to run it, I can see that the trained actions actually come back like these ones. Like, they're not the other ones, it's the 3 that I trained for. So I know that the file that is saved with my brain data actually knows that this is the 3 actions I trained for. So somehow in my C++ code afterwards, it's just not actually detecting when I'm doing the actual thought, which is fine. It's probably my C++, it's probably the code that I wrote, because I don't know C++, so there's probably something wrong in there. So I know that this is the thing that is not working. The thinking, the thoughts in Node is not working, but it is working when I actually try live in the panel. But then the facial expressions should work. They do. Same backup video. But if I try again, and I saw that it crashed again, which is a bit annoying. Let me just relaunch it. OK, so I'm connected. And if I do that, and I connect to the actual engine, and I smile, no, you can't let me down again. No, not that. Oh, I did blink, yes. Yeah, OK, I do have a smile. It's important because it's important for the next demo. And I should have, OK, so the eye direction was working before. For some, I'm not frowning. OK, see, it's going a bit crazy. But yeah, all right. So see, well, I do get some comments. It's not me, it's the sensor. All right, so you can see that when I was trying it, maybe you can't see, but you could see that eye direction was actually working pretty well. So maybe, I guess it depends on the day. I don't know. I have been refactoring a few days ago, which maybe is the problem as well. You shouldn't do that before a talk, but I did. So that's probably my problem as well. But you can get some stuff, so you can get started there. And then what I worked on is to try and control the drone with the brain sensor. I actually did that this morning, so I haven't tested it, but it should work. I thought let's just do this. So what I have is like a parrot mini drone that connects to your computer via Bluetooth. And I'm waiting for the little eyes to be green, because now they're red, which means it's not connected yet. And, OK, so I did do this. And I think that if I smile, it should take off. And then it should land. But it's orange. I want green. Come on, give me green. Do. I'm just going to do it. Oh, not that. That. Oh, it's green. OK. OK. Give me the other. OK. Wait. Yes. No? I'm trying. Come on, I can do it. Hey. I'm smiling, but I'm OK. Why? No? Did I? I'm going to do something. Don't look at this. Don't look at this. Yeah. Don't look, it's very horrible. Blink, smile. Yeah, that should work. Let me try again. OK, so. OK. So I know it is connected. And now. No? Hee. Totally letting me. Oh, wait. No, not left. Smile. How can you just get the word? OK. Left. No, but. Oh, wait. No, what is all this? Wait. So you can see it works very well. You should totally work with brain senses. You know what? I'm going to do something. Look again, away. Oh, a dinosaur. Wait. Let me just. This is prototyping code, I'm just saying. Just checking if I get this. Yeah, OK. So I did get blink. And then I should get smile. And smile should do this. Yeah, what kind of makes sense? Ooh, good away. Just give me one thing that works. Isn't it not? I'm gonna, OK. I'm not leaving here until it works. Ooh, OK, what about if I do blink then? If you like blink, I'm going to give you blink. All right. OK. Oh, come on. Smile and blink? No? At the same time? Yay, no. For fuck's sake. All right. Seriously, I don't want to give up. I don't want to give up. You have to. You were working, like, kind of. And now you don't even want to connect to this anymore. No. I feel so alone. Come on. All right. No. OK. It doesn't even want to connect to the drone anymore. So, yay. Let's just imagine it worked. I'll just post a video later. So yay. In terms of resources, I just put some links of the stuff that I used. Epoch.js at the top is the name of the framework. Obviously, as it works very well, I'm sure you're all going to use it. And at the moment, the version, like I've started refactoring, so please don't even check it. It's really horrible code. And if you want to try and do that kind of stuff, you have the Node add-on examples as well. I'm just going to remove this now. Ooh, all right, and I have a shell over my hair. But yeah, OK, so I just wanted, yeah, so special thanks, of course, to Rebels for having me. You probably won't have me anymore. But these people are very great support for me. I wouldn't be speaking here if it wasn't for them, so I just wanted to little shout out. And thanks a bunch to you guys for being here. Actually, people, not guys. That's it, I'm done. I'm so sorry. Damn it.
So there were a lot of tweets that said
no.
this is like the good tweets. They were like, this is the
This is
bravest
rubbish, money
demo.
back.
No, bravest demo I've ever seen.
That's a good one.
No, that was amazing. I was on the edge of my seat. That was like, I've watched movies that are supposed to be tense that were much less intense than that. So every time I see new tech, I think, how can this be used for emojis? And I'm wondering, how close am I to thinking poop emoji and then having it appear on the screen? Is that tech possible?
You can have access to the raw data as well. I mean, you have to pay $50 per month. But then if you apply some machine learning, I'm sure you can get like, poop emoji,
Yeah.
and it's like on the screen.
Okay, so big data, the cloud,
Yeah.
machine learning, brain sensors, poop emoji.
Yeah.
Does that sound like the tech stack I
That's all
need?
you need.
What got you interested in this?
I think I was always interested in like little gadgets when I was a kid. But then when you start being a programmer and you know that you can actually program for these things, I think what I don't like is when you buy something and you just have to use what's like the app that other people have built. So you're kind of like constrained to what is given to you. But as a programmer, you can really take it to another level and do whatever you want with it. So like I actually saw an example of people who built an app for the emotive where it could control a wheelchair. And I find that amazing.
Wow.
And one of the other things I wanted to try was to build a kind of an interface where there would be a keyboard and you could actually write with your eye movements. So I started working on that, and it's not working, and I probably know why. But yeah, that's like you can. Like, I just love the fact that when you know, like sometimes you can just have a crazy idea, and programming kind of gets you there. So
Yeah. That was so. What do you want to do next with it? You said the eye tracking app. Make it work.
I would love to be able to make it work. Yeah. I mean, if I even just get the thoughts of like the actual action thoughts working in JavaScript, then I mean, in a way, it's kind of useless. What would I do? A game, maybe, but that's not. I mean, like I would probably move on to the next step. I am really interested in machine learning now, so I wanted to kind of try and. I don't know if you saw the Google little device that uses machine learning to detect micro movements. Project Soli, I think. And I wanted to kind of redo that where you actually have a sensor and you kind of train the sensor to recognize some movements using machine learning. So you feed it some data and you can kind of create your own patterns of movements. I found that super cool.
Huh.
So, yeah.
You mentioned that you would move on kind of after this. And at the beginning of your talk, you mentioned how much you like creative coding and building things that are useless. They're not like business applications or something. How do I frame a question out of this? Do you think that's something that more developers would be helped from doing? That's a bad question. Should more developers do that?
Yes.
Is it beneficial for developers?
Well, I like to do it because it kind of opens the doors to things that you may not have thought about before. So it could be even in the browser, creative coding, now you can do it with like WebVR, WebAR, and 3D and stuff. You can do things that you really, like I wouldn't have known I could have done that until I actually started and I tried and I was like, oh, what about this and what about this? And then you can really mix a lot of stuff. You can use the emotion with the processing language and do visuals, and you can do art installations with code, and I find that really amazing. I think that probably a lot of people don't do it because they maybe don't know. Maybe they're not interested, but that's another.
Another thing I really liked about your demo was how you could open up the code and just say like, oh, blink, I'll change the smile thing to blink. And that to me just is part of the power of JavaScript, right? If that was all in C++, it would be harder to do that on stage in front of people and worry about messing things up. Do you think that more hardware should have interfaces to JavaScript like this so it's more accessible to people?
Well, more accessible, yes, but then it's not as performant, and like you can see, it's just not working. So.
Are you saying it would work if it was in C++? I haven't heard that argument very much before.
But I mean, I do appreciate the fact that people working on JavaScript frameworks really make it more accessible. Like I probably couldn't have started doing the Emotion and Sphero if I didn't find a framework that I could read. I would have probably been scared if the first thing I wanted to do would have been like C++ in front of me, and I would have been like, you know, like one of the GIF is like, I don't know.
Yeah.
So yeah.
Yeah. Well, that was great. Thank you so much for
Thank
presenting.
you.
I really enjoyed it.
Thank you.
Our next speaker is Arne Martin Arlien. He is a web developer, a partner at a small agency. I want to read one of his tweets because he made the mistake of posting his Twitter profile. So I'll be presenting at Web Rebels. Do I know what I'm doing? No. But do I promise to do my best to give a fun and useful talk? Also no. I think he's lying. I think that this talk will be fun and useful. Please give him a round of applause.
Thanks, everyone. Okay. As has already been said, my name is Arne Martin. I answer to Arne, or just whatever you like. I live in Trondheim, and I work at a small, like, two-person agency called Kvitebjørn Design Bureau. Kvitebjørn is an old Norwegian word for polar bear, so that's, in case you were wondering. I'll be giving a talk about compiling to JS today, which is a thing that's done a lot these days. There are many programming languages in the world, in case you didn't know. But if you're developing for the browser, there's really only one. And outside the world of, well, us, JavaScript is not always as beloved as it maybe should be. It's a language that has its charms, but it also has its quirks, and it has a fair share of whats, as you maybe know. But it's not the only alternative. There are several languages that use JavaScript as a compilation target that allow you to write code for the browser in whatever manner you prefer. I'll just go over a few of the most common ones now. The most common one is probably something like Babel, which lets you write JavaScript from the future and compile it down to gross old-style JavaScript of today, like our ancestors used to write. You can write code like that and have it compile into actual JavaScript. There's TypeScript, if you like JavaScript but want the added safety of having some types. There's CoffeeScript, which you can use if you like white space and hate everything that's good and decent in the world. There's ClojureScript. If your 8 and 9 keys are all worn out on your keyboard, that's probably what you should use. There is Elm, if you like Haskell, which is something as rare as a friendly and useful language inspired by Haskell. If you love Haskell, there's PureScript. But how do all these languages work? There is some code in the language that is not JavaScript. Then something happens, and then there is JavaScript code. How does this even work? So let's talk about compilers a bit. This next part applies to most compilers. The JavaScript part is almost incidental in this. Before we go any further, I have a small warning to you. I don't really know this stuff. I have never worked on a real compiler or did anything remotely similar to writing a real compiler. I have a degree in computer science, but I never took the compilers class, so just take everything that I say today with a grain or two of salt and you'll be fine. That's out of the way. What does a compiler actually do? Compilation happens in several steps. What those steps are and what they do and what happens in each step usually varies a bit from compiler to compiler, but I'll try to cover the most common case here. The first part of compilation is lexical analysis, or tokenizing or lexing. The next part is syntactical analysis. I'll go into what these mean in a bit, so you don't have to worry. There is AST transformation, and then finally, code generation. So what is all this? First, what are tokens? The tokenizer or lexer takes the string of your program and turns it into a more structured representation. It basically takes everything in your program. Say you have the following JavaScript program. It takes every bit of that string, chops it up, and turns every piece into a token and adds it to an array. So that may look something like this. Every piece of the code is represented in this array. So that's tokenizing. These tokens are then passed into syntactical analysis, which produces an AST, or an abstract syntax tree, which is a data structure, like a tree-shaped data structure that represents everything in your program. So for the same JavaScript program, the AST might look something like this. This is a simplified example. You see there's a call expression. The function being called is the log method on the console object. The argument is a binary expression down there. Yeah, as I said, it's a bit simplified compared to what you'd see in a full JavaScript AST, which usually has like where in the source code is this located and everything, so you can have source mapped and stuff. The next common step is transformation, which converts your AST into a different AST. That usually means converting the AST for the language you're compiling into an AST that's more compatible with the language you're targeting. And it's usually done by walking the tree. There's a function that walks down the abstract syntax tree and visits each node in the tree in a depth-first manner and generates a new syntax tree based on this walk. After AST transformation, there is code generation. If you're using like a real compiler, what you get, the end result will probably be some binary byte code or machine code. For us, we get JavaScript. So for my example, let's say you have this JavaScript function. And in my example, it doesn't actually compile to JavaScript. It compiles to some stupid version of Lisp, but that's just an example of what it could look like. So a compiler takes your source code, breaks it up into bits, shuffles all those bits around, puts them in a tree, and creates new source code or binary code based on the final tree. I'll make a brief aside into something that's actually important and relevant, but I won't be covering it apart from this slide. That is parser generators. A parser generator is another word to say another way of saying compiler. You define your language. You define the grammar of the language you're compiling in a structured way. And the compiler takes this representation and generates a parser for you that will take in some source code and generate a syntax tree or maybe even the final program. For JavaScript, there is one called JSON, which is nice. It's a thing that exists, and I will not be covering it any further because I want to get to the nitty-gritty details of this for my code demo in a moment. So we come now to the practical part of the presentation. I have made a programming language for you that we will be writing a compiler for. It is probably even simpler than the simplest programming language you could imagine. It's called the dice roller language. If you played Dungeons and Dragons, well, I haven't, but I know that there are dice involved in this game. You roll some dice, and typically D&D players, they use like a jargon for this. They roll like a D6 is a 6-sided die, and a D12 is a 12-sided die. So if you say 1d6, that means roll one 6-sided die, like a normal die. So if you say 1d6 plus 2, that means you roll one 6-sided die and you add 2. You will get a number in the range 3 to 8. If you roll 2d8 plus 5, you will get somewhere between 7 and 21. So what would this look like in JavaScript? Something like this, maybe? It's basically just a bunch of math at random, added together. So that's the idea, that's what we want to make. So we want to have every step of the compiler represented there. So we start with the tokenizer. The tokens for this should maybe look something like this. There are 3 types of tokens. There's a dice, an operator, and a number. A dice can be like 2d6 or 5d8 or whatever. Operator is plus or minus, and number is, guess. And the syntax tree for this would look like maybe something like this. There is an operator expression, which is basically an addition. And it has a left-hand side, LHS and RHS, a right-hand side. The left-hand side of the addition operation is a dice expression. This also has a left-hand and a right-hand side. The left-hand side is how many dice we roll, and the right-hand side is how many sides that die has. So should we? Yeah, let's just try making this. Let's go to Emacs. Thank you, Bodil. So let's start with a tokenizer. This function should basically take, it's on screen, right? Yeah. Should take the source code as an argument and return an array of tokens. So we start by setting up the tokens array. We also have a variable called pos that will maintain our position in the source code. And we return the tokens at the end of the function. Okay. What I do here is basically just to add a space to the end of the source code for technical reasons. I won't go into that. And then we basically iterate over the entire string of the source code, character by character. We set variable C to whichever character we're looking at right now. In between here, we'll add all the functions for generating the tokens. If we get this far in the loop, there is something that's not been caught. Something is unrecognized, or just throw a type error. That's maybe not the most friendly error messages, but this is not actually a production-level compiler. So first, we check if the character we're looking at is a plus or a minus. It's a very simple case. In that case, we add a new token called operator. The value of the token is the sign, so either plus or minus. We increment our position, and we continue. Go back to the top of the loop. OK, simple. There are 2 more types of tokens, numbers and dice. We'll use the same piece of regex to identify both. So we set up that regex here, a digit between 0 and 9, or the letter D. So if the character we're looking at is matched by this regex, we do the following. We keep looping and popping new characters from the source code and adding them to the current variable until whatever we have doesn't match this regex anymore. It's basically keep going until we hit the space or something else, something that's not a number or the letter D. After this point, the variable current holds whatever the current token is. And it may look something like this. It could be 9, DDD, DD9, 8, DD9. And that's obviously not a valid dice, so we have to check for that. So first, we test if it's a dice. This regex checks if the token has 0 or more digits than the letter D, then 1 or more digits at the end. Okay, it's a dice. We push the dice token, and the value is whatever the value was. Then we check if our current token is just digits. If it is, it's a number. Fine, we push a number. Beautiful. Otherwise, we have something that's not recognized. So we throw another type error. Why not? Invalid dice expression. Okay. There is one more thing that we have to think about when we're compiling this language, and that is white space. And white space is just ignored. We just skip over it, go back to the top of the loop. So if we have anything in our program that's not a plus or a minus or a number or the letter D or a space, we get this far and we get an error. Okay, that should be the entirety of our tokenizer. We can see if it works. If we have a program that's 2d6 plus 3, and we run it with our tokenizer, looks nice. We have a dice token, an operator token, and a number token. Beautiful. So far, so good. Now we go into the next part, which I'll call the parser, which takes our tokens as an input, and this will generate the syntax tree for our program. Start by defining the position, which is our position in the tokens array. We start at the first token, and we keep going through. The AST is a tree structure, not a simple array. So we define a function here called walk, which will create this syntax tree, and we'll call it recursively when we get a bit further. So our program should be the result of calling this function. And the parser should return this data structure, which is the top-level AST. So the root AST node is of type program, and it has the body, which is the entirety of our program, which we will compile. We start by getting the current token in the tokens array. We define a variable called current, which will hold our current AST node that we will create. Similar to the tokenizer, if we get this far, something is wrong, and we throw a syntax error. Right. We have gotten a token from the tokens array. If the token exists and is of type number, fine, we can use that as is in the AST. We set our current AST node to just be the number token. Simple. Otherwise, this is more code, this is not as complicated as it looks. If the token exists and is of type dice, we split it in two around the letter D. So we have a first part, the part before the D, and the part after the D, which would be two numbers. And we set our current AST node to a dice expression, which has a left-hand side of the first part of the number, or 1 if there is no number defined. If it's just D6, we just add 1 in here. The right-hand side is the number after the D. So for 2d6, the left-hand side would be 2, and the right-hand side would be 6. Okay, so far so good. What we do after this is we try to fetch another token from the tokens array, and we increment our position. If there is a next token, and the next token is an operator, a plus or a minus, we return a new AST node of type operator expression. The operator is the token value, so either a plus or a minus. The left-hand side of the operator expression is the current token that we created in our previous part here. And the right-hand side will be a recursive call to this walk function, which will then just keep looking at the next token in the tokens array and just try figuring what the next part will be out. I think if we don't have a next token at this point, we just return the current token, and then the parsing is done, and we have a complete AST. Okay, does this make sense? You're being very quiet. Yeah? Yeah, a few laughs. Yeah, okay. Let's try if this works. We'll try it on the same program that we had for the tokenizer. And we'll try parsing it. Okay. Looks good. We have an operator expression with a plus, dice expression, 2d6, and the number 3. That looks fine. We can work with this. The next part of a compiler from my bullet points earlier is the AST transformation. We don't really do that for this simple language. So we'll skip over that part and go straight into code generation, which will take this AST and turn it into beautiful JavaScript code. Hopefully beautiful. So this generator function takes our AST as a parameter. Here we also have a walk function that will walk the AST recursively and generate code from all the bits of it. At the end of our generator function, we call this walk function on the body part of our AST. This is quite simple. This generator function is the simplest part of the code for this compiler. We simply do a switch over the type of the AST node. And we set up a case for each node type. There's a dice expression, operator expression, and number. If we have a dice expression, we do this, which is basically we create a string that contains this floor math.random part as many times as there are dice. And we join that together with a plus, so we just join all the maths together. Quite simple. You get this? Yeah. Sure you do. You're smart. If we have an operator expression, a plus or a minus, we do this. We return the following string. The operator is in the middle here. And then we do a recursive call to our walk function on the left-hand side and the right-hand side of the operator expression node. Should work, right? If our AST node is a number, that's very simple. We just return it. So this function should take our AST and create a stringified representation of our program. Okay. Let's see if this works. 2d6 plus 3. And we run. Yeah, you see it down at the bottom of the screen? It's cut off a bit. I'll just move this a bit over. There you go. Looks right, yeah? Let's do 4d6. It's a much longer string. Nice. Let's do 10d6. Yeah, beautiful. Now is the part you've all been waiting for. We'll try to run this code and see if it actually works. We just wrap this whole thing in an eval. And we run it again. 10. Yeah, looks reasonable. 12. 9. 10. 11. 5. Yeah, all this makes sense, I think. Let's do some, yeah, thank you. $48 plus 3 plus 96. Should work too, right? Get a higher number, 46. Yeah. Gorgeous, I think that's my last code, yeah. Okay, as far as my presentation goes, that pretty much does it. I thank you for joining me on this ride through compiler land. I hope you learned anything. Don't use this in production ever. Slides are on GitHub if you want to look at them. I'm on Twitter. The name is up on the screen. Thank you very much. If you want to talk to me about Emacs later, just...
There were some questions about Emacs.
Ah, great.
I like how you managed to give a presentation on abstract syntax trees and still make fun of Dungeons and Dragons as being nerdy. That was a good trick.
Well, I said I haven't played it yet because that's because I don't have the right friends.
Yeah.
That's not because I disrespect people who play Dungeons and Dragons.
Yeah, that was a joke. Yeah. I know you don't disrespect people who play D&D. Another question was, what were your slides written in?
I have my own custom-made terminal-based slideshow thingy, which takes a bastardized version of a markdown parser and generates this beautiful terminal stuff from it.
Does it like encode the images into terminal escape codes and all that stuff?
Yes.
Wow, that's amazing. Your talk was really good too. I'm sorry.
Thank you.
We're going to talk about your talk also. But the slide thing was cool. So you mentioned that you didn't take a compilers class. How did you learn all this stuff? What resources do people use to get into this?
Wikipedia.
Okay.
No, I just find this stuff interesting. So I've been looking at a few of the compiled languages that I mentioned. I've been looking a bit into them and looked at how they're made, and
So you'll pull open the compiler for CoffeeScript.
Yes, and I've
okay.
seen like the terms like tokenizer and lexer and parser and all this thrown around. So I just thought I'd look into what all those terms actually mean, and try to do something meaningful.
Yeah, is there a specific language that has kind of an approachable compiler that you would recommend people look at, or should they just check them all out?
I don't know. I think the CoffeeScript compiler is written in using JSON, which is the parser generator that I mentioned earlier.
Okay.
If you're doing a serious, real language, a parser generator should be the way to go, is my opinion. It handles a lot of stuff and error cases and makes it a bit simpler.
Sure.
It will you define how all your tokens look and how they are allowed to fit together. So if you have tokens in the wrong order, you will get error messages.
You get like smart error messages
Yes.
instead of it's broken.
Yes.
Yeah. Another question from the audience was, what was up with the Nyan cat in the bottom of your Emacs?
Oh, yeah. That's Nyan mode for Emacs.
Okay.
It just displays your position in the buffer.
Cool. One of the things I liked the most about your talk was the example language. I've seen a bunch of tutorials about compilers, and it seems like we will compile this simplified version of Lisp down to JavaScript, and taking something that isn't even quite a programming language and showing how you would compile it, it really helped me understand, like, oh, you can apply this to anything. this much more abstract thing than some kind of magic that generates code.
Yeah, I thought about what language to use for my presentation. I thought about doing a Lisp or maybe some other like more serious language type, but I thought I'd just do the simplest thing I can think of. That's still applicable. So.
Yeah, that was great. How does knowing about compilers and knowing about the tool chain that goes into them help the average web developer? Say you're not writing a compiler for Dungeons and Dragons or dice rolling. How would it make your life better?
I don't know. I don't have a good answer for that. But a fun thing to do is look into how tools like Babel and stuff works and how they do AST transformations.
Mm-hmm.
There is a fun website. I don't remember the name, but it allows you to type in any JavaScript code, and it will show you the abstract syntax tree for that code.
Oh, is that
AST Explorer? Or something,
yeah, I've played with that.
That will show you what the syntax tree will look in, like a bunch of different JavaScript parsers. That's really interesting to look at.
Yeah, it's you mentioned Babel, and that's such a big part of the JavaScript workflow now. It seems like it might be helpful as a developer to kind of take away some of the magic of that tool that you depend on so much. And,
yes,
and
very much.
like, someone could do that. I could do that. Cool. Well, thank you so much for your talk. I really enjoyed it. It was great.
Thank you.
Our final speaker of the day is Jared Forsyth. Jared is a developer at Khan Academy. He helped build React Native. He made the React dev tools. Most importantly of all, he lives in Utah, which is where I live. So we're basically neighbors. He's here to talk to you about type systems and how type systems can make you a better JavaScript programmer. Please give him a round of applause.
All right, thank you very much. So as he said, I'm going to talk about type systems. And I work for Khan Academy, where we're working to build a free world-class education for anyone, anywhere. And I work on the mobile team, which means that I spend a lot of time in Java, Objective-C, and Swift, in addition to doing a bunch of JavaScript. So I've seen both worlds, right? I've seen the power and the safety that you can get from one of these compiled, kind of very well-typed annotated languages, but I also love JavaScript. And I love the flexibility and the prototyping speed that you have with it. And so I think if we can bring a more formal type system into our JavaScript, then we'll reap a bunch of those benefits. Before I start, here are some things that I like that are cool. If you're interested in any of these things, come talk to me after. I'd love to talk about them. In general, I'm really excited about helping programmers have an easier time of things. We have these computers that are so smart and so fast, but they're so dumb. And there are so many things in our programming workflow that are slow or annoying, or you'd think a smart computer would be able to do this for me. So that's kind of what ties all these things together. But what am I going to be talking about today? First, I want to try and convince you that you need more type errors in your code. And then I'll talk about how to get that, and what changes when you have a powerful type system at your disposal, and how that changes the way that you think about and how you write code. And then I'll just touch briefly on what lies beyond JavaScript type systems. So you might be thinking, no, Jared, I want fewer type errors in my code. But I think you'll find that you actually want more. To start out, I'll just define a few terms. For my purposes, I'm going to say that a type represents a group of things that can be used interchangeably. I just love this GIF of a baby. You've got the square thing, and there are places where it can be used and places where it can't. And sometimes you just throw it out, right? And you'll find that actually in JavaScript we do that a lot. We just kind of bypass all of the things. So in JavaScript, we have types. You can think of numbers as a type. So you've got multiplication and subtraction. And regardless of what number you stick in there, it'll at least make sense. It'll give you a reasonable result. Strings have similar operators. You can concatenate strings together. You can take a substring. And we can also think about type that is the group of objects that have a name attribute. So you can say, I have a function. If you give me something with a name attribute, I'll do something reasonable with it. And if in JavaScript, if you do type of X, here are the types that it'll give back to you. It's a small list. Mostly you've got the primitives, and then function and object are just huge. I mean, just about everything you work with is either a function or an object, and JavaScript doesn't really distinguish between this type of object versus this type of object at the type level. So if those are types, then type errors are when you try to use a thing in a context where it doesn't work. And it really depends on the language runtime and your perspective to decide what really is a type error. JavaScript has a very limited view of what type errors are. There's really just blank is not a function and cannot read property blank of undefined. In my example earlier, passing in something that doesn't have a name object where you expect one, JavaScript doesn't care. Here's one of the problems that happens because we have such a limited vocabulary for type errors in JavaScript is that you get the wrong error at the wrong time. In this simple code example, you've got x equals 10, y is x.parent, and you return y.name. Clearly, looking at this code, the problem is that numbers don't have a parent attribute. But JavaScript doesn't complain until the third line, saying undefined does not have a name. Now, you might be thinking, off by one, right? You look at the code, you can see it. But in the real world, it's off by thousands, right? You see this undefined is not a function, and the actual problem, the code change that caused it, is many call stacks away, many files away, and you spend all your time hunting down, logging values, throwing in breakpoints. So you've got one of these, where your code doesn't work. Clearly, there's an error, but the actual problem is so far removed from what JavaScript tells you that you spend a lot of time hunting for it. But even more problematic than this is when JavaScript doesn't give you any errors at all. Right? Here's an example function. You do something, and it expects an argument that has a name attribute, or has a count attribute, sorry. And if the count is larger than 2, then we say it's large, otherwise it's small. And we're passing in a number that clearly doesn't have a count attribute, but JavaScript thinks that's fine. The count is undefined here, and we all know that undefined is not larger than 2, so it'll just return small. And so you're left with one of these, where you look at the page, and there's clearly something going on that you didn't expect. But you don't have an exception to tell you where it's coming from. You don't have a traceback. So again, you're logging out all these variables, trying to figure out where did that not a number, or where did that undefined kind of creep into the code because of something that in reality is a type error. It's using something in the wrong place, but JavaScript doesn't care. To give it credit, JavaScript's trying to give you the benefit of the doubt, right? It says the programmer's smart. They probably meant to divide 2 by the empty string. And the answer is infinity. This is great. But it really backfires because JavaScript tries to avoid throwing type errors at all costs, you end up spending so much more time debugging. So hopefully at this point you're with me in that we need more type errors in our JavaScript. We need more kinds of type errors so that it'll be more expressive and we'll be able to tell, okay, what is the actual problem here? The first line of defense is actually linters. And you might be thinking, what do linters have to do with types? But they do know about 2 types. There's declared and not declared. And in non-strict JavaScript, this code wouldn't even be an error, right? I've typoed argument, it's Bergman. But JavaScript would say, oh, that's fine, it's undefined. Undefined plus 1 is not a number. We'll just return that. If you have strict mode on, then at least you get an error at runtime. But even there, a linter helps, because it tells you before you run the code that there's a problem. So linters run ahead of time. They're very little work, but they're also super rudimentary. The next line of defense is custom runtime checking. And you've probably run into this, especially if you look into the source code of a well-used library, where the author of the library wants to make sure that clients get useful error messages when they use the functions wrong. Because JavaScript doesn't care about argument length or argument types, the author of the library goes in and checks, is it the right number of arguments? Do these have the right types? Let's say, for example, we've got this Greek function that takes a string, a list of strings, and a number. And so the bottom 3 invocations are errors. And if we didn't do anything, they might return just something weird. They might return not a number or undefined, or they might throw, undefined is not a function somewhere down the line. But we want to be nicer than that. We want to be informative to the client about what the problem actually is. And so first we check the length of the arguments. If it's not 3, then we just bail. But we also want to make sure that they give us the right type of arguments. And so, being the defensive programmer that you are, you start adding more of these if statements, more of these errors. And it just gets out of hand real fast. This isn't particularly readable. It's not going to be fun to maintain. And in many cases, you have more lines of code just checking the arguments than you have doing the actual logic. And so unless you are the maintainer of a really popular library where you want to be really friendly to your users, it's just not worth it. So custom runtime checking is very powerful, but it's lots of extra code, and it's only at runtime, right? Your IDE is not going to be able to take advantage of these checks that you've got and tell you beforehand where the problems are. Now, if you're familiar with React, React has this thing called prop types, which are essentially custom runtime checking done right. It's much easier because they provide all these functions for you, and they do the checks themselves, so it's not cluttering up your code. You just say, this component wants a greeting that's a string, and months that's a list of strings, etc. And at runtime, React will check, was this component called with the right arguments? And it'll do a console.warn if it wasn't. So this is nice. There's not too much extra code. It's nice documentation. You can see you look at a component and you can see exactly what it wants because it's very readable. But again, it's only at runtime, and it only applies to React components. It's not going to work for your other functions. So now we come to the static type checking, which is what I want to sell you on. And I'll be using Flow for these examples, but TypeScript is also awesome and does many of the same things, so the same principles apply. Here's a little primer on what it would look like to add Flow annotations to a function. We've got our sayHello function that takes a name that's a string and returns a string. And these annotations will look familiar to you if you've written any Swift, or Rust, I think, uses a similar pattern. There are a bunch of languages that have these kind of annotations. So we can annotate a function, but we can also annotate variables. We can say the value of this variable ought to be a number. But one of the great things about Flow is that it has very powerful inference. And so most of the time, you don't even have to add any annotations, and Flow will know, clearly, that's a 10 literal. That's going to be a number. It will also infer from function calls. sayHello returns a string. Greeting will be a string. And actually, in this case, we can just remove the annotations from sayHello because Flow will be able to infer those as well. And I found in the vast majority of the code, Flow already knows what the types are, and I add type signatures just for my benefit so that I can read the code better and it's self-documenting. So here's what it looks like in comparison to the custom runtime checking I was doing before. Right? Much more concise, much more readable. This is what it looks like compared to React prop types. And you can tell that the folks building React prop types were very much inspired by static type annotations because they're very similar. So static type checking runs ahead of time. It integrates with your IDE, so you know already what the errors are going to be. There's not too much boilerplate. It applies to everything in your code, and even things you don't annotate yourself. And it's just wonderful for readability. It's so much nicer to go into a big code base that is fully Flow annotated than it is to go into a normal JavaScript code base, and you're looking at this function, and you see that it takes an object, right? A config object is the best. And you have to search around for function invocations to be like, okay, what does this even look like? And it's even better when different invocations pass different things, and so it all looks really hard to track down. So I really like tables because they let me show unequivocally that the thing I like is the best. So take this for what you will. But I think it lays out some of the pros and cons, some of the things you can weigh. At Khan Academy, we've been using Flow on the mobile team actually for over a year. We've got some JavaScript where we tie the native code to an embedded web view. And we really want that code to be rock solid because anytime you're dealing between two different platforms, it can get hairy. And so that is fully Flow typed. And then on the web front-end team, we've been using Flow types for about 6 months. And so out of the thousands of JavaScript files that we have, about 300 or so have Flow types in them. And here are some of the reactions from just within the team, what they think about it. One experience we've had is many times adding Flow types to an existing large file, it finds bugs that were in there. Bugs that we hadn't come across or that we hadn't fixed. Our users may have come across them, but they didn't tell us about it. And so that's a really nice feature where it's just like, oh, there's a bug already there. I can just go ahead and fix it. It really helps if you're on a large team. With a bunch of people making changes to a single code base, having Flow to back you up will make it much less likely that you'll wreck things for everybody else. And then, again, it's just a lot easier to read. It's not all good, though, right? Sometimes integration with editors is a little finicky. It's getting better, though, but it can cause you some headaches. And adding a new syntax of these type annotations on top of all the new ES-Next stuff that we're learning can have a real cost for a large team, and so that's something you want to weigh. So far, I've talked about how having type annotations and having this more powerful type system at your disposal will help you debug better. It'll catch bugs for you. You'll be able to refactor with confidence. But I think even more important than that is the way that it changes the way you think. Could I get a quick raise of hands? How many people have used Flow or TypeScript in their JavaScript? Cool. How many would use it again? Awesome. So hopefully you're already sold on this, but you can take these lessons and use that to sell it to your coworkers, to your boss. Because there is a real cost, and oftentimes people look at this, they look at adding type annotations to JavaScript, and they think, we already find bugs on our own. This is going to be a whole lot of extra work, adding all these type annotations, and what will it give us? Right? Maybe we'll find bugs faster, but is it worth the cost? I would argue that from the bug finding alone, it really is worth the cost. But even more than that, it will make your code cleaner and more readable. So that's what I'm talking about here. I'll start out by talking about clever code, and then implicit invariants and implicit state machines, which are very related, and then how writing down data types can improve your code quality. What I mean by clever code, there's this really good quote on the internet where talking about how code is so much harder to debug than it is to write the first time. And so if you're feeling super clever when you're writing code, you just don't have a prayer of debugging it. And that's happened to me a lot, I can tell you. This is kind of what I mean by clever code. In the first instance, we've got a props object, and we want to set the on mouse down or the on click to be a function. And you want to do it in one line, and so you've got this little ternary, and you do some string concatenation, and it's awesome. It's actually not super awesome, not very readable, and Flow is going to have a hard time figuring out what the result of this is. It's not going to evaluate your ternary for you. And so this second example is, 4 more lines. It's a 500% increase in lines of code, but really it's much more readable, much more maintainable, much less likely to have bugs in it if you were to misspell one of those strings up there. Another thing that's super common in JavaScript, it was a lot more common a couple of years ago, but it still happens, is when people take advantage of the fact that JavaScript doesn't care how many arguments are in your function or what the types of the arguments are. And so you just go crazy. And you've got these functions that if you pass in 4 arguments, then it's a number, string, string callback function. But if you pass in 2 arguments, then it's a configuration object callback function. And if it's 1 argument, then it's just the callback function, and it returns this, so you can chain. And it's like crazy to get your mind around. And for one thing, Flow would have a really hard time figuring out what the type is. You would have a hard time writing down the type for that function. But even more than that, as a client of a library, I don't want to have to remember a dozen different ways to call this function. Just give me one way so that when I'm looking at the use case, I know exactly what to do. So in general, I've found that if some code is hard to type check, it's probably going to be hard to understand. The next way that having a type system in mind helps your code maintainability is with implicit invariance. Now, an invariant is a guarantee, and if it's implicit, that means it's not enforced anywhere. It's not in the code. You'll have it in your mind when you're writing the code, and you might write it in a comment, but nothing is enforcing it. As an example, I'm going to use React for my code here because that's what I like the best, but the same principles apply if you're writing Angular or Ember or Vue. A common thing that you do when you have a component is it depends on external data, so you need to load, and while it's loading, you show a little spinner, and then if there's an error, you show an error screen. Otherwise, you render the happy path. In this case, the happy path is a button that wants you to click it. And the state that we have to worry about is whether or not it's loading, and then an error that's potential error and potential data. Now, the question mark in front of the string and the sum object mean that it's an optional type. So error might be null or a string, and data might be null or some object. Because at the beginning, when you're loading, you don't have either of those. So this is all well and good until you try and create that on-click handler. And let's say we want to alert the name of the data. And Flow will complain here saying, no, you said that data might be undefined at any time. So you have to add a check. You have to convince me that data is not undefined. And you might be thinking, I wrote this code, I know it's not going to be undefined, because the only way that onClick could be called is if the button is rendered. The only way the button gets rendered is if we have data. How hard is that? But this is an implicit invariant. One way to fool Flow, to get around this, is you just throw a bogus error. And if you find yourself doing that, you probably need to take a closer look at how you're structuring your data, because this will bite you, right? Someone will come in not knowing that these invariants you have in your head apply, and call the function in the wrong way, render things in the wrong way. And it's actually not very hard to restructure this so that onClick will never be called if data is undefined. You just have to create a child component, make it so that onClick literally can't be called if you don't have data, not that it just won't be called because you wrote it that way. And here's what that might look like, right? We make the contents component that takes the data as props and then has the onClick handler and uses that. And so the way that the code is structured enforces the invariant that you had in your head that onClick would never be called unless you had data. A more advanced example of this is with implicit state machines. Now, a state machine is a thing that can be in multiple different states. An example of this from the Khan Academy mobile app is in the exercises part where you can do math problems. And to start, there's a loading screen where it loads up a bunch of different problems for you, and then you start answering the problems, and you go through, and once you've finished all the problems, then it shows you a congratulations screen that has points, how many points you earned, and any badges that you earned. And the kind of naive way to go about this, to think, okay, what data will I have involved? What's the type of my state object? Is to just kind of list out all of the state that's involved. Right? We've got loading that's a Boolean, Problems that is an array, but it's not there at the beginning because we're loading. Answers is also an array, but again, it's not there at the beginning because we're loading. Current problem will be an index, just a number. And points data will load at the very end, so it's optional. And then it'll be present in the final screen. And this is what that kind of state object would look at these various different stages. Right? You've got loading is true at the beginning and nothing else matters, and then answering, loading is false and problems and answers are populated, and current problem is something reasonable. And then finished, nothing really matters except for the points data that we've got. The problem with this state representation, the type that we've created, is that it allows for invalid states. Again, here's the state type. And what happens if loading is false, but problems is populated, but answers is not? And again, you're thinking, as the developer, I wrote the code. As soon as we get the data, I set loading to false, and I populate both problems and answers at the same time. This will never happen. Trust me, it will happen. Right? You come back in a couple weeks, or your coworker comes in, doesn't know what these implicit invariants are that you have in your head, and it breaks. Now, in a language like Swift, this is a structure that we could use, an enumeration that has different cases. The loading case doesn't have any important data, and then the answering case has the problems and answers and the current problem, and then the finished case has points data. In Flow, we can use a tagged union, which is essentially the exact same thing, but it allows us to use normal JavaScript objects to represent the same thing. So there's a loading screen, and then the answering screen with problems, answers, and current problem. And you'll notice here, problems and answers are no longer optional. So we're now enforcing the invariant that we had in our head that if problems is there, answers is going to be there as well. And then the third screen doesn't care about the other data. It just has the points data. So if you're going through and you're creating a component that has a bunch of state and it goes through transitions, and you find yourself making a bunch of things optional, it's probably that you're trying to represent a state machine, but it's not going very well. So consider using a tagged union or one of these constructs to make explicit the invariants that you have in your head. The last thing that having a rich type system kind of pushes you towards is to think about types in an explicit way, right? If you're going to have to write down the types, I've found myself at the beginning of a project thinking, okay, what is the data going to look like? Let's write that down. For a hypothetical blog post app, I think about, okay, what is the post type going to be? And let's write it down. I'm not advocating for a Java style, like create a class hierarchy and a UML diagram. This is essentially the same thing as a database schema. But you can create it for all of your JavaScript data objects. And it makes it easier to think about, okay, how am I going to structure the code? And much less likely that you'll run into errors later on. So these are the ways that having types, having a rich type system in JavaScript will change the way that you think about and write code. But Flow or TypeScript, they're an 80% solution. They have escape hatches out of kind of pragmatism because JavaScript isn't always well formed. It's not always sound. And you add types incrementally, but there are ways to get out of it. As you remember the kid doing with the blocks, you just take off the box. One way that happens is if you're using an external library, by default, Flow will just make everything the any type, which is like all bets are off. In this function, I'm using the _.pick function, and I want to return the name. I've got a spelling mistake, but even if I didn't, I would have a type error because I'd be returning a string when I claim to be returning a number. Even if I fixed the typo, Flow would have no problem with it because I'm using this external library. Now, you can add type annotations for external libraries, and you can add those module definitions. But this is a thing that will bite you if you're not wary of it. And then the other place is when you've got a deadline, you don't want to worry about typing out the types and figuring out what it is. You just say it's any. And again, all bets are off for type inference and type checking with respect to those values. And in our code base at Khan Academy, I said we had 300 some files that are flow typed. About a quarter of them have any types in them. Because pragmatism, because it's hard to type or we don't have time and there's a to-do, type this later. And unfortunately, 80% typed might mean that all of your users see errors. So we've got these compromises in Flow and TypeScript. And I just wanted to touch briefly on what else is out there. Like, what if you want more? And the two things I'll talk about are Elm and Reason. Those are my favorites of the vast landscape, but there are many more if you are interested. And the things that Elm has going for it has really good community, really good documentation. And the build tools and the publishing tools are very well made. But the interop with JavaScript is very restricted in the interest of soundness, right? They want to make sure that to the greatest extent possible, everything type checks. And so they don't have kind of the compromises that you get in Flow. But it's also a fairly young language, and to be honest, I'm very opposed to Haskell-like syntax. Like that might not be a thing for you, but Python's okay. Curly braces are great, and I can't handle the syntax. So Reason is something you might have heard about. It's kind of been developed for somewhat over a year. And it's based on OCaml, which is an incredibly mature language, a really awesome type system. And there's a culture of pragmatism that helps you get things done. Like you can have mutable variables if you need them. You frequently don't need them, but sometimes you do. And the JavaScript interop is really good. So it's much easier to incrementally add Reason to your JavaScript code base. And if you're interested in it, it has a native compile target, so you can compile to native. But I'll warn you, the documentation is terrible. OCaml is a very academic language, and they haven't really focused on kind of outward outreach or community quite as much as these other languages. And the reason folks are still trying to get build tooling in a shape that's not terrible. So this is kind of another table. You can find all these slides, by the way, at jaredforsyth.com/typesystemjsdev if you want to go over this afterwards. But again, there are caveats. I think Reason is super interesting if you want to go that way. Elm is awesome. Lots of people are using it in production and are very happy about it because they don't have runtime errors anymore. But but TypeScript and Flow are kind of the more pragmatic options. If you do want types, but you're not ready to switch to a whole different language. And one more thing before I close. People often ask me about Flow versus TypeScript, right? There's kind of lots of debates. These are my opinions that aren't at all based on the merits of the type system, really. You can see comparisons of, like, this has this feature and this has that feature. But Flow, we chose Flow at Khan Academy because it's good for incremental adoption. We already used Babel and Webpack in our tool chain, and so adding in Flow is easy, whereas TypeScript wants to kind of own the whole system. And that's really nice if you're starting a new project and you don't want to mess with Babel config, you don't want to mess with Webpack. But if you're trying to integrate with a current thing, that can be more difficult. So in conclusion, JavaScript doesn't give us nearly enough type errors, but static type checking can help tremendously. And once you have a rock-solid type system in your tool chain and you get used to it, it'll change the way that you think, and you'll write better code. And if you get frustrated with the 80%, there's more out there. Thank you very much.
That was great. Thank you.
Thanks.
So I have questions. The audience has questions. They also said nice things about your talk. One question I had is, how do tests fit into this landscape where you have a lot more tooling checking your code for you? How do you know what to test? Do you not need tests anymore? Can you talk about that a little bit?
Yeah. You definitely still need tests. There are a lot of tests.
Shucks.
There are a lot of tests that are obsolete if you have type checking, right? In kind of the current JavaScript ecosystem, and also in other like more loose languages like Ruby and Python, there's a strong culture of you test everything, and you write a test to make sure that it returns the right type, and you don't have to do that anymore because you have the types that are checking everything. So there are a lot of kind of menial, annoying tests that just go away, which is nice. But
Sure.
you still want to have tests to make sure that the logic is sound, right? Because the type system can't check that.
That makes sense. What would you say to people that have maybe had experience with other type systems and have not liked them?
Right.
A lot of people learn Java in school or as a first language. Java is fine, but some people have criticisms about its type system.
I'm totally with you. I was scarred by Java early on. I now write it professionally, but I was really unhappy with Java for a long time. And Flow is much nicer to use than Java. Because it has all this inference, right? You don't have to write down types for everything. The minimum it requires is adding function signatures for anything you export. But within a file, any functions or components that you have, you don't have to write types for them, and they'll be inferred. And then the other nice thing that Flow has over Java is that the type system is actually more powerful. It's very much inspired by OCaml's type system. And so if you've had annoyances with Java where it's like, oh, I can't really express this, or generics are mostly fake.
Screw it. It's a map of string to string.
Right. Then Flow will hopefully be better for you.
Sure, that makes sense. A question from the audience was, so Flow and TypeScript, they look like great tools, they look helpful, but they're not standards, and you're kind of, it is another language, right? It's a superset of JavaScript, but it's still, you're not fully in the JavaScript camp anymore. So if you're already going to write something that isn't technically JavaScript, why not just go all out and write a compile to JS language? Does that make sense?
Yeah, well, that's where the interop story comes from. With Flow, the only thing you need, if you're already using Babel, then Babel will strip out type annotations anyway. And so all you need to do is install the Flow package and add the Flow comment at the top of the file, and you're good to go. Right? You don't have to convert files over. Whereas setting up a whole new tool chain to get Elm into your project or to get Reason into your project can be a lot of work, and frankly, much more expensive than it's worth, especially if you have a large team. Getting everyone on your team to learn this new language is much more expensive than saying, by the way, like, if you've got colon number, that means it's going to check to make sure that's a number.
Sure, that makes sense. I think this one is a tricky question. How do you type check dynamically download a JSON using Flow? So part of that is like, how do you handle runtime stuff? And the other part is, how do you handle, you see this a lot with like custom fields where people can add new fields to a form or something. And then now you have these extra fields that might be there, but they're user generated. How do you handle really dynamic stuff like that in Flow?
It kind of depends a little bit. One way to take this question is, I'm downloading JSON, but I know what it's going to look like. Or I know that it will fall into one of these three camps. And so then you can do a check, does it have this tag on it, does it have this tag on it? And then you add the flow type to say, now I know that it fits this shape, and I'm going to promise flow that it looks like this, and then all the guarantees will follow from that.
Sure.
So there's definitely places where you do checks at runtime, and then you hand it over to flow and say, okay, it's all good.
So there's kind of like this barrier between the dynamic stuff and the flow code.
Yeah.
That makes sense.
And flow can actually oftentimes use those if statements that you have to automatically infer, okay, it's of this type as opposed to of this type, which is really handy.
Yeah, that's cool. I think the last question is, what size of projects does this make sense on? Is there a certain size where you say, like, okay, we have X number of lines, so we should really be using a static type system, or is it fuzzier?
I'll tell you that when I start a project, I want to go fast and loose on a side project, and I want to prototype, I want to move quickly, but invariably there comes a point where I'm looking at the code and I'm thinking, I really wish I'd added flow types to this last week, because I have no idea what's going on.
So the size is like 500 lines smaller than the time you decided to add it.
Yep.
Okay, that makes sense. So use a time machine.
That's right. Yeah, I mean, it's nice because you can add things incrementally.
Yeah.
Right? You can mess with something, and then once it settles down, you go in and add your flow types. And periodically, I go through a phase where it's like, I don't want to mess with flow, I'm just going to turn it off, and then I play with things for 2 days, and then I turn it back on and just spend an hour and fix everything.
It's kind of like a spike of crazy looseness, and then
yeah,
that makes sense. Awesome. Thank you so much for your talk. It was
Thank
great.
you.
So that'll do it for the first day. Can we have another round of applause for all of our speakers? They did such a good job. Great talks. Thank you, everyone. A few final announcements. The dinner and drinks are at the Scandic Hotel at 6 p.m. Your drink tokens, reminder, those are worth 120 krone. Also, if you tweeted nice things, even if I didn't read it out on the couch, come find me. I'll give you one of my drink tokens until they run out. And then come find me anyways, because I'd like to talk to you all. Breakfast starts tomorrow at 8 a.m., and the conference starts at 9. So we'll see you at the party and then tomorrow at the conference. Thank you.